Welcome everyone to day 4 of our AWS Certified Solution Architect Associate 2022 Bootcamp. This is a free AWS Solution Architect certification course to help you pass that AWS Certified Solution Architect Associate exam. Now, we do these free AWS certification trainings because we want to know that you have access to the knowledge of what's on these exams. But also, we've seen what's out there, and all they are is the name of a service and how to configure that service. And we architects don't really configure any services, but we need to know what they are, how they work, and why to use them. And that's why I do these free AWS courses, because in your cloud architect career, you can't just know how to configure things. You need to know what they are and how they work. And that's why at Go Cloud Architects and Go Cloud Careers, our mission is to make sure the entire world that wants a cloud architect job can get a cloud architect job, or a solution architect job, or any cloud computing job for that matter. Now, that's why we do this. Now, this course, this AWS Certified Solution Architect Bootcamp, our free full AWS course, will prepare you for the AWS SAA-CO3 exam, and it'll also get you the 50% or more of the way through the AWS Certified Solution Architect Professional. And this is an AWS Cloud Computing full course, so let's make sure we have some fun. Well, I've got a contest winner and some exciting things to tell you about, but before we do, I'm obsessed with knowing that you're awake, alert, and oriented, so you get a good experience here. So if you can all give me a hashtag, AWS Certified Solution Architect Associate, and a hashtag about where you're at right now. So I know where you're at, I know you're paying attention, and we're gonna have a great time. Keith, I'm thrilled to see you here again. I was hoping you'd be here all week. And so wonderful to see so many of you here. Now, when you guys are giving me my AWS Certified Solution Architect Associate hashtag, as well as where you're actually at, I'm going to be going over some of the amazing free things we have coming up for you to make sure you get cloud hired. So I'd like you to all know we have a completely rewritten AWS Certified Solution Architect Associate and Professional exam guide. More than 100 people worked on this thing with hundreds of years of total combined experience from various technology specialties, and it's going to be yours completely free. It goes along with the book. Download it. It should be part of your library. Tell a friend to download it. We want anyone that wants a cloud job to know how to get a cloud job. Now, because we're focused on making sure you understand the technology, because that's what it takes to get hired, we still want you to get hands-on the technology. Look, we cloud architects don't touch the technology, but I'd still like you to do it at some point so you can say to an employer, I've done it. So because configuring the cloud is so easy, you can just literally go to the AWS website and read the instructions, but we still wanted to walk you through some labs. So in order to do that, please sign up for the completely free AWS lab demonstrations. The link is in the description below, as well as the chat box. Sign up for the free labs. You'll be logged into our learning portal, and then you can do these labs on AWS. Because I want you to get it, but I want to make sure that we focus our time on making sure you have real cloud knowledge as opposed to superficial knowledge. Now, if you're trying to get your first cloud architect job, we have our Cloud Architect Career Development Program, which is 30% off right now using coupon code SECURITY. If you're an architect and you want to become a senior architect, a principal architect, or a distinguished architect, we've got our Tech Career Accelerator program. And if you're trying to interview for a job and you're all ready, and you know you're ready, we've got our Tech Interview Mastery program. I've been involved in tech for 25 years. I've never gone in an interview in case I didn't get a job, because I've been studying interview tactics, psychology, behavioral science, neurolinguistic programming, interview tactics and techniques for more than 2.5 decades to help you get cloud hired. So take advantage of coupon code SECURITY too. Completely build your best cloud computing career. Now, we have a winner for the competition to win your free scholarship to the Cloud Architect Career Development Program. But before we announce that winner, let's talk about next Thursday's webinar. Next Thursday, we will have our completely free How to Get Your First Cloud Architect Job webinar. People come from around the world to these webinars. I will tell you exactly what the rel is, how to leverage your life experience or past work experience to show the hiring manager competent, even if it's a different career. We'll go over exactly what hiring managers want in the perfect cloud architect, the skills that you need to get hired as a cloud architect, what needs to be on your resume, how to skip HR so you don't get auto-rejected when you have no experience. And again, it's going to be all free. Now, Chris, would you like to announce the winner of the first competition? Because we have 3 more chances for you to win this competition.
I'll let you do it, Mike. It's a surprise for you. I'm just going to pop the name up there and let you let you go.
Okay, pop the name in the chat box.
I got to find the
Ask
name.
my team to pick the winners.
All right. All right. So here we go. The winner is.
Well, the winner is Collins. He's in Lagos, Nigeria. And Collins, let's give you a round of the hand and let's give everybody a hashtag Collins / AWS Certified Solution Architect. So Collins, welcome, congratulations. We're super, super excited that you're winner of this contest. We'll have 3 more contests coming up through. So Collins, congratulations. Winner of week 1's contest. We are thrilled for you, Collins. I can't wait to see you in class. We'll get to meet. It's going to be a wonderful, wonderful, wonderful time. And make sure you have all the skills to get cloud hired. Love these contests. Fantastic. I'm loving it. I'm loving it. I'm loving it. So congratulations, Collins. You'll be getting an email from my team with a registration link. And I can't wait to see you in class. It's going to be fun, 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 helping you get your first cloud architect job. So what are we going to talk about today? And bear with you guys, everybody. This is a special turmeric, ginger, and a whole bunch of other anti-inflammatory things placed in a tea for my laryngitis so that I can keep going despite having laryngitis to make sure you get the best cloud architect bootcamp we can possibly give you. So today we're going to talk about security on the AWS platform. Now, when we talk about security, realize this is just a subset of security. This is an AWS Certified Solution Architect Associate course. So we're going to cover the AWS security services and the associate and professional exams. Now, remember, in real life, security is much bigger than this. We're going to be using things from the marketplace, next generation firewalls, but they're not part of your AWS exam. And we need to focus on the exam. That's why this is a solution architect certification versus cloud architect training. But it's on your exam. Your exam is going to help you get the interview. And then it's your knowledge after the interview on cloud computing that gets you cloud hired. But we still want you to get that interview. So in this section, what are we going to talk about? We're going to talk about who's responsible for what parts of your VPC. We're going to talk about principle of least privilege, which I like to call need to know. We'll talk about industry compliance, identity and access management, multi-account strategies, network access lists, security groups, the AWS version of a firewall called WAF. We'll talk about the AWS's intrusion detection systems. We'll talk about DDoS mitigation. We'll talk about the service catalog, and we will talk about the systems manager parameter store. So we're going to begin by security. Who is responsible? And the reason we're going to deal with this is normally in your own data center, you're responsible, right? You're responsible for all your firewalls, your routers, your switches, your QoS policies, your identity and access management, everything. But that's because you own the data center. You manage the data center. And if you manage the data center and you want to hire Navy SEALs, snipers to be on the roof, you could do that. And you can hire whatever level of security you want in your data center. Now on the cloud, you don't have access to that because the cloud provider manages their infrastructure and you manage your virtual infrastructure. So when we deal with this, we're dealing with this shared security model. And you can think of it this way. AWS maintains the security of their cloud, and the customer maintains the security of their virtual cloud or their virtual data center. So when we talk about security, we can only control our stuff. If the cloud gets hacked into, we have no control over that. So we have to trust that our cloud providers are doing a great job doing security of their own systems. And for the most part, they are. Now, they're not invariable to hacking. They get hacked too. We've seen it in the past few years. Azure was recently hacked. And we know that anybody can get hacked and everybody will get hacked. It's just a matter of when. But you manage the security of your virtual private cloud. AWS manages the security of the underlying hardcore tech infrastructure. So let's talk about what that means. It means the customer is responsible for the identity and access management, users and roles, and we'll talk a lot about that. Patching of the operating systems of our virtual machines, maintenance and security of our own applications, configurations of our security groups, physical security for the devices that we're dealing with, our own firewalls, for example, that we're going to use inside of our systems, pretty important to us, whatever intrusion detection prevention systems we use, and the gamut of our own security services. So that's kind of what we maintain. And of course, AWS manages the security of their infrastructure. So I drew it out for you to try to make it a little easier for you. You can see on the bottom, AWS manages the servers, the BIOSes and their servers, their hypervisors. They manage their storage area and networks, whether they be block storage, object storage, file storage. They secure their databases. They secure their networking. They secure their regions, their edge locations, their data centers, otherwise known as availability zone. Now, what do we secure? Let's make it a little simpler. Our data, our applications, the operating systems and our virtual servers, any kind of encryption of our data we're using, any kind of networking traffic that we're using. For example, you could run IPsec over our direct connections or over a VPN. So there's that. And that's kind of what we're talking about. Now, the first concept whenever you get into security is the principle of least privilege. I hate this term. I like to call it need to know. Military makes it simple, need to know. And here's what it means. If you don't need to know anything about that for your job, you're not told about it. If you need to know it, you're told. And here's why. The more information you have, the more you can harm the company, either maliciously by going to a competitor and selling your secrets, or by accidentally disclosing information you don't even know, or by using a system in the wrong way and damaging things. So the principle of least privilege is very critical. It basically says give your users the least amount of access necessary for them to perform their function, and no more, no mas. Only what's necessary to do their jobs and nothing else. And when somebody leaves your company, when they're walked out by security, lock their systems down so they can't damage you. So principle of least privilege means as follows. Provide only the necessary features, functionalities, and access that somebody needs to do their job, and nothing else. And when they leave that company, you revoke it immediately. And that's why organizations, just to let you know, actually have security walk people out. And sometimes it's the saddest thing in the world, and I've seen it over the past few decades happen a lot. Sometimes the only way somebody finds out they were laid off is their email doesn't work. They can't log into the systems. They call a help desk, and all of a sudden they find out they've been laid off. Now, this is a horrible, horrible situation, but that's why it's going on. And I've seen it happen so many times. Not good companies, well-run companies don't do this, but it happens, and it happens more than you would like to know. So let's look at this in another context. Here I am, and I'm an administrator. I need to access something, and I basically got authenticated by the system. The system says, yes, Mike, you're allowed to do this, and yes, you're authorized to do this, and I'm allowed. Now, by comparison, we've got another user that's not me. And this user's not allowed to do their thing. And because this user's not allowed to do their thing, they're denied, access denied. And this is really what we're talking about by using the principle of least privilege. So before we get into real security concepts, and we're going to get into a lot of them, let's talk about industry compliance. Many industries have all kinds of security regulations and requirements, data retention, etc. And AWS, like all cloud providers, supports the main industry compliance. And you can see a full list on the AWS website, but the main ones I'll cover, PCI DSS for payment cards, sure. ISO 9001, 27001, 27017, 27018, pretty standard requirements. AWS supports them. FedRAMP, if you're going to do anything with the US government. And HIPAA, which is basically, healthcare U.S. privacy rules and regulations. Now let's get involved into identity access management. And this is a key part, last line of defense in your security architecture. Last line, not first line. Now, I hate the term identity access management because it sounds so fancy and complicated. I'm going to simplify it. Many years ago, before we used word inflation, we used to call a spade a spade. We called coffee coffee before it became a latte and all these other funny things. And we used to use the term AAA, authentication, authorization, and accounting. And I'm going to cover those concepts because I want you to truly understand this IAM or identity access management. Authentication, who are you? Who do you claim to be? I'm authenticating right now. I am Michael Gibbs, CEO of Go Cloud Careers. Now, they could authenticate me via retina check. They could use my, my fingerprints. They could authenticate me via DNA. They could authenticate me via a password and a username. They can authenticate me via something you have and something you know, like your ATM card and your PIN number. So authentication is who are you? So the first component of identity and access management is who are you? Now the next component is authorization. So let's talk about what authorization is. Authorization is what are you allowed to do? So we can't have all users accessing all things. I'll give you an example. Chow Pham, she's an incredible cloud architect of mine. She works in our team. She's absolutely amazing. If Chow says to me, Mike, I'm going to come visit you in Florida, I'd say, thank you, Chow. Can't wait to see you. When she'd knock on the door, I'd look at her and I'd know she's Chow because I've seen her before. Then I would give her the keys to the house, give her the keys to the Mercedes, and tell her to go in the house, take the guest bedroom. My wife would prepare all the things for her, and Chow could have access to every room in my house. And that would be authorization. Now, by comparison, if it wasn't Super Chow, the amazing cloud architect that walked into my house, and it was a stranger, I might look through the peephole on the door and say, get out of here. Or I might question them, and they say, I need to use your phone. My car is broken down. Maybe I bring my phone outside to them and let them use the phone. Or maybe I allow them to come in, and I stand by and I stand guard. See, authorization. And the key is we're going to give different privilege levels to different people based upon their need to know and how trustworthy they are. So authentication, I identified as Chow. Authorization, I told Chow she can do anything because I totally trust Chow. Now the next thing is accounting. That's the last part of this AAA concept. And I'll give you the example of accounting. Chow comes and visits. She stays with us. She plays with my cat Cindy. My wife gives her all the things that she needs. And then after Chow leaves, my wife checks and says, Chow used 3 shampoos, 4 bars of soap, ate 22 cans of tuna, which all really went to Cindy because she kept opening cans of tuna for Cindy. So I need to go to the store and I need to buy 22 cans of tuna, this many bottles of shampoo, and this much soap. So that's called accounting. Now, so identity and access management is really about who you are, what you're allowed to do, and then keeping track of it, or building an audit trail so you can find out after the fact. Now, when you're dealing with AWS, they're going to define the concept of users and roles, and we're going to get much more into that depth later. But here's the thing you need to remember. A user is a person, like Superchild, the amazing cloud architect. That's a user. A role, generally speaking, is a computer, meaning one system accessing another system. You may have been involved in Linux and you're familiar with the term service account, which is typically used like in your 3-tier web application. We've got your web servers, your app servers connecting to your database, and the service account connects your application servers to your database. So if you've got an EC2 instance accessing DynamoDB, that would be a role. But if we've got me accessing a system, I am a user. So while we're at it, let's look at this concept again. Authentication. User signs in and we know who they are. Maybe we use a username and password, a one-time password, something you have and something you know, but whatever the case, that's what we're using. Now next, after we've identified that user, we have to authorize that user for what they're allowed to do. And then after that, we have to track that user. So that's the basis of authentication, authorization, accounting, otherwise known as identity and access management. I don't make up those terms. Somebody else does. Let's talk a little bit about IAM users. Users are identities, people that have the permission to access or interact with your resources on AWS. What are your resources? Your virtual machines, your containers, your storage, that kind of thing. Now it's created by a principal. We'll get into the term principal and what that means later. But in other words, a systems administrator needs to grant you access to things, otherwise you won't be able to reach it. And we can create our user accounts, with the management console, the command line interface, or the software development kit. That means pushing it over the API. And IAM users are permanent unless deleted by the administrator. So think about this. Somebody works for you, they get a job going somewhere else, and you have to remove their access, you must delete their account. So let's look a little more into this. We've got a user. You can see the user logs in, they identify themselves, and you can see they have access into their proprietary NoSQL database or the object storage or anything that's sitting on a virtual machine. So let's talk a little bit about authentication options. Let's talk about the simple ones and get better. At the simplest name, username and password. Hi, my name's Mike, and my password's name is Cat. No, you'll never find me use a password named Cat, but you get the concept. Username and password. Log into the console, enter my username Mike, enter my password named Cat, and of course I'd be hacked in about 3 seconds with a password like that, so I would never use something like that, but that's your username and password. Now what if we want something a little better? We can use something called an access key. And an access key is a combination of a 20-character key ID and a 40-character secret. That's some security there. And this access key you would use to connect to AWS via an API. One system connecting to another one, done over the software development kit, so to speak, and you're pushing some decent security between systems. Now, if we want to get even better, we can use an access key and a session token. And what we're dealing with here is when IAM authentication needs to occur under an assume role or secure token, we're going to use the token alongside the access key. Now that's going to maximize our security. Now, I know I briefly covered what is authorization, but I want to do it again. Authorization occurs by determining what specific things you're allowed access to. And these are going to be policies that are going to be written. You can give it to a user or a group or a role. So let's talk about it. Hi, I'm a user. You can add specific policies for me under authorization. Now, let's say you've got a company with 200,000 employees. Do you want to add policies per user, one-on-one, manually, 200,000 times? I don't think so. So what you could do, and we'll talk about more of this later, is you could create groups of users, network admins, sysadmins, cloud architects, finance people, HR people, and then you could apply a policy to the group. And then when you hire someone, you hire 5,000 new solution architects, put them all in the solution architect group, and they inherit the permissions of the group. Much, much more scalable. That's how everybody does things. Now, when we write policies with regards to AWS, they're written in JSON, which is otherwise known as JavaScript Object Notation. And the default policy for anything with IAM is deny access to everything until you configure it. Now, there's 2 ways that you can set up your systems. Allow everything until you lock it down, hacked in 3 seconds, or allow what you need. So that's why they start lockdown. Now, when it comes to a policy, there's a few things that we have to determine. The effect first. Do I allow Cindy access to the room? If the answer is yes, I allow. If the answer is no, because the room's full of birds and my cat Cindy likes to eat birds, the policy is denied. Now, we also, under the authorization policy, need to define the service. What is the cat allowed access to? Is the cat allowed access to S3? Is the cat not allowed access to the room? Is the cloud not allowed into a room because it's full of birds? So the effect, allow or deny. The service is what we're protecting or not protecting. And then we put the resource. Now with AWS, we have the opportunity to use a full Amazon resource name, And by doing this, we can point to the exact resource that we're allowing access or denying access to. Now, the last things that we're going to talk about under this policy include the action. What is the permissions of the user? Read, write. And we can add some conditional elements, which are optional but very granular. Maybe to allow access to a certain subnet at a different time during the day. So go through, so now you get what they're actually dealing with. So let's go back to looking at authorization again from a graphical perspective. Here we see we've got a user. This user's allowed access to object storage, otherwise known as S3, and DynamoDB. But when they try to get to that management console, they're not an authorized user, so they are denied. So now when they're dealing with AWS IAM concepts, I talk about some more critical things that'll be on your exam and you need to know it to create a policy. We'll first talk about a principal. All that a principal is an IAM entity or something, meaning a user or a role, that has permissions to access something on the AWS cloud. Let's talk about the root user, the king, the queen, whatever you want to call it. When you first create the account, you're creating the root user, the person that's the owner of the account. And when you own the account and you're paying for the account, you have unrestricted access to anything. So of course you're going to be the root user. Now don't log in as root because you could accidentally delete your entire organization by mistake. And if any of you have ever been Unix users or Linux users, and you've been told don't log in and root as work as root, it's the same thing. Because you can't restrict access to the root user. And one little silly thing, and it's gone. Now, when you have a root user, don't use the password cat. Because somebody could use the password cat, which they can crack with a GPU in less than 5 minutes. Poof, they've used the password cat, and now they're inside of your systems, right? And now they can spend $1 billion on systems if they want to, and it's going to be built to you. So use a strong password. Now, realistically speaking, you should also secure that strong password somewhere, maybe on a key in a safe that's locked down inside of a safe and another safe and another safe. Depends on your systems and how critical they are. And maybe enable multi-factor authentication on your root account, so it's not just a username and password. And don't use for programmatic access, meaning don't use this key on a computer that's connecting to another computer, because when that computer gets hacked, your whole account is hacked. You think these things sound very simple, but the reality is I've seen it all done before. So let's talk about this root user. You'll note that I had the graphics person put a crown on them, because if they're the crown queen or the crown king, root has unlimited privileges inside of your virtual private cloud, otherwise known as your virtual private data center. So let's talk a little bit more about identity and access management. Identity and access management is used to determine whom can access the system. It uses standard concepts like users and groups and access control policies. These are the same things that you'd be dealing with a Radius server, for example, or a Microsoft Active Directory server. And the plan is we create a group. Create a group for the security personnel. And they all get security personnel positions. The accounting team, the finance team, the system administrators. But remember, as I mentioned before, could you imagine writing 200,000 security policies? No. But what if you're AWS and you have 20,000 solution architects? I don't know how many they have. You put them all under a single policy. It's better than that than making 20,000 single policies. So here's how the groups work. I create a group, cats. I provide permissions to the group. The cats can open and close the back door, but they can't enter the bird room. And then I add all the cats' names to the room. Cindy, Sunny, Catty, Noni, any kind of cat I want is allowed to the group. Now that cat has the same permissions. They all have the same permissions. So if my cat Cindy and Sunny are under the same permissions, and Sunny can't enter a room, Cindy can't enter that room either, which would make Sonny the cat probably not so happy, and Cindy the cat not so happy either. As I mentioned before, roles are generally systems. And we're going to talk about several kinds of roles. We're going to get a little bit in the weeds here. It gets a little complicated here, so please bear with me. There are a few kinds of roles. There's what's called a service role for EC2. Here we got two service. A service role allows this system into this system. Simple, easy, elegant. There's a cross-account role, which is when you go from one AWS VPC to another AWS VPC as a rule. And there's an identity federation. Let's be fair. No serious business is going to be using the AWS IAM system. They're going to be using Microsoft Active Directory. All their users are going to be in Active Directory, and they're going to connect to Active Directory and pull that Active Directory information into AWS. It's called federated identity, and we'll talk much more about that. But understand this, roles enhance security by making sure the credentials are never stored anywhere. You don't want to put a password in a computer to attach another computer, because if one computer gets compromised, guess what? Your entire systems are compromised. And the way roles enhance security is, what will happen is the AWS service, the API, will provide a temporary token for the system that has to access the other system. And here's what's so great about the token. They expire. I give you a token and it's only good for an hour. You can use it for an hour. Now, the token will change in an hour. Now, if a hacker got access to your token, the worst case scenario is they can use it for an hour. Now, 45 minutes of the hour pass, the hacker gets control of your token. They can only use the system for 15 minutes. And guess what? At the end of the 15 minutes, they can't access anything because the token's been expired. That's why we love them so much. So IAM roles are used for one system to access another system. IAM roles can be assumed by applications and services. IAM roles use short-term credentials, meaning periodically, which substantially enhances their security. IAM roles will basically leverage the security token service, which I'll talk more about. And tokens are temporary. The default expiration time is 16 minutes, but in a really high security environment, they can be reduced down to 15 minutes, or they can be extended to 36 hours to promote additional scalability. Now, talking a little bit more about IAM roles, they are typically used to grant permissions for applications running on EC2 instances. IAM roles are really used by people when connecting to external identity providers like Active Directory, or using your Amazon account or your LinkedIn account. IAM roles are used to grant permissions to IAM users in the same account to a different role, and grant permissions to different accounts. It's called a cross account. Logged into my VPC is paired with Chris's VPC. That's called a cross account role. What I'm going to do is briefly mention the security token service, and then we're going to take some questions, and then we're going to get deep into the roles. So most of these roles require something called the AWS security token service. What that is something that's designed to provide trusted users access with a temporary token, but the tokens expire. Here, I request access, I get given my token, I'm allowed access to the system. When that token expires, guess what? It's no longer recognized by AWS, and we are done. And the hacker, if they got it, gets access to expired information. So let's do this. Let's make sure we get some questions for you. To make sure, if you don't have any questions, we can keep going. If you do have any questions, I want to make sure we answer them. Does anybody have any questions? Please ask them in the chat box. You guys are awfully quiet. I want to make sure you're here.
Yeah, they're very quiet. I don't think anybody's here.
Quiet scares me. When I don't hear from people, I don't know if I'm talking to people. Folks, I'm here with laryngitis. I've had it all week. I'm drinking this turmeric and ginger tea. Doctor has me on cortisone. I want to know that you're here and you're learning. You guys have any questions? Because I will make you all the world's greatest cloud architects. And while you got, and in order for me to know that you're awake and I didn't put you to sleep, give me a hashtag AWS Certified Solution Architect Associate, and I'm going to go out there and answer some questions. Listening in quiet mode's okay, but when you participate, you always learn more. But I do like that palm tree. Jennifer, you're here. Fantastic. Thanks a lot. Is it possible to take the solution architect without the cloud practitioner? Oh, of course. We tell people never to take the cloud practitioner whenever possible. Go straight to the solution architect. How can you monitor a user with the administration privileges? Well, that's the key. Any type of identity and access management strategy you have, it'll still log everything they've done. It'll log the root user. It'll log a traditional IAM user. So you're going to go to your identity and access management logs. And that's why I said we do authentication, authorization, and accounting. Accounting is exactly tracking everybody, including me. If I own the account, it's still going to track me. Great question there, Gutson. Chris, we go to the next one. Can we talk why we would use Active Directory? Lady Godiva, Active Directory is the IAM system that is used by every system. Now, why wouldn't we use the AWS IAM system? Well, here's the thing. We're going to be dealing most likely with enterprise email, which is going to be using Microsoft Exchange. We're going to be dealing with servers and Windows servers that have Windows quotas for their users, and specific Windows applications that all businesses need to use. And because of that, every business is going to have an Active Directory server for the most part. So why would we worry about trying to do this manually on AWS when we already have the information somewhere else? So we're going to be using always a federated identity and access management strategy, because otherwise we're still going to have our Active Directory. And now we're going to be dealing with another set of stuff to deal with, the AWS stuff. So why would we ever deal with AWS? Microsoft made Active Directory for the last, as long as I remember, and they are the de facto standard for identity and access management. And that's when we were dealing with things. That's, the separation between certification and reality. Businesses use Active Directory for IAM, and that's why we'll be using it in the cloud or off the cloud or anywhere in between. Good question there, Lady Godiva. What is the AWS Security Token Service? So anytime we're dealing with systems accessing other systems, what we're really dealing with is, do I put a username and password on the computer? And if I do, I got application server connecting to a database. Here, I put the username Mike, password Cat on it. Now it's connected to my database. Now my system gets hacked. The password Cat gets figured out, which would be a crazy password that nobody should ever use, hopefully, and they get in. But by using the token, what'll happen is we've got the user. They want to access the database. They'll hit the token server. It'll come back from the token server. They'll get a token. They'll access the system. So that's the security, the AWS Security Token Service. Token is basically automated, and you set it up for the amount of time you want the token to expire. Exactly, guys. Good question. In real life, would a solution architect get access to the root user? James Yang, in real life, the solution architect is never going to touch any of this, ever, and will never have access. Like when we interviewed, for example, what's his name? Romanik Ivan Tamba, and he said, we're not allowed to cut our customers' networks ever as solution architects. Solution architects will never, ever, ever touch the cloud. We design it and present it and sell it. We don't build it. That's solution. That's engineers. Even though the token expires while the hacker has compromised your system, isn't that still bad? Yes, because they may need only 5 minutes to do what they need to. Look, if your systems are properly designed and somebody gets access to your systems, they may need days or weeks to inflict harm. And that's why we're not going to be using a lot of the services we're going to be talking about today. We're going to be using multiple sets of next generation firewalls, multiple layers of access lists, security groups. We're going to be chopping our VPC into hundreds of VPCs, running BGP policies and security between them. And by doing it that way, nobody's hacking a system in 5 minutes. They might need 5 weeks to do it. How would you use Active Directory? Very simply. You set up federated identity and access management, which we'll talk about soon coming. Can I elaborate a little bit on federated identity? Yeah, sure. Have you ever gone to a website and they say log in with Facebook? That's federated identity. Log in with your LinkedIn account. Log in with your Apple ID. There you go. Can I use AD instead of Cognito? It depends upon the application. How does AWS IAM allow access? Like any other authentication system. You enter a username and password or any of the access keys or any of the things that we taught. I don't really understand your question. Can admin privileges be given to a specific region? Even though the resource is shared across multiple regions, there's lots of ways you could lock your systems down. Lots of ways.
So normally I wouldn't do any career-related questions, but
I definitely want to answer Dennis's question because it's simple. But if there's another one, I'm going to answer it as well. Would you recommend Solution Arc in Azure after AWS or Snowflake? Well, I wouldn't do Snowflake. Well, it depends on your career. I wouldn't do Snowflake if I had any interest in being like a cloud architect or solution architect. You have to understand what the role is. It's a role where we design, present, and sell. And Yasmin, it's not about knowing Snowflake or any of these things. It's about understanding the customer. It's about understanding their business and understanding which business problems they have. We're not engineers as architects. So for example, I need to be able to understand when the customer says, I want to improve revenue. When the customer says employee productivity is low, I need to know what that is. When the customer says, we've got a new opportunity, but we have too many manufacturing defects, as an architect, I need to think about what technologies can I use to solve that problem. Focusing on Snowflake is going to turn you into an engineer, and it's going to make it harder for you to be hard. But focusing on business skills and leadership skills and sales skills, that's going to get you there. Are root users and IAM users the same name? Not at all. A root user could be an IAM user. A basic admin could be an admin user. People in any role would be an IAM user. Basically, an IAM user is anybody that has access to your systems. Root users like the king and the queen. Does the token renew with your credentials every so often? Yes, it does. Like maybe change your username and password. Tokens renew every 15 minutes to 36 hours based upon the way you set them up. And they constantly change. Is it possible to restore a security token? No, you would get a new one. What are best practices to manage access to AWS resources? We covered that in the beginning. Principle of least privilege. Give people only the access of what they need and no more access. The military would call it need to know. Dennis, if you can't touch the client's network, how do we know what we need to improve? Dennis, you interview the client. I need to increase sales. I need to improve employee productivity. I need to save money. I need to this. So some of that information we'll get from their balance sheets. Some of it we'll get from their financial statements. Some of it we'll get from the engineers. Some of it we'll get from documents they share with us. Some of it will occur when we bring in 30 cloud engineers or 40 cloud engineers to baseline their systems, and they review the finding. Dennis, if you're an architect, you got to focus on improving business performance, not the tech. The tech is just a tool. So we focus on the customer. How do we know what to fix? The customer tells us what problem they have. Kind of like when you go to the doctor and you say, I have a sore throat. Like right now, I've got a sore throat because I have laryngitis. I go to the doctor. He's going to ask me questions. What makes your throat better? What makes your throat worse? I'm going to tell him what my problem is. Then after that, he'd do an exam, make a diagnosis. But here, the architect is asking the questions. He's going to bring in some engineers to do the exam. Then the architect will make a diagnosis and build a treatment plan and then go design that plan and go sell it back to the customer. And then engineers will go build it. What's the difference between IAM? IAM is who are you, what are you allowed to do, and what did you do? Single sign-on means you log into one system, which we'll cover more later, and it gives you access to other things without logging in 10 times. The alternative would be, and I'm sure you, if you've been around long enough like me, you would log into the corporate intranet, then you would hit a web server, have to log into that, then you'd hit another internal server, have to log into that, and then it became a real problem. And for these kind of things.
All right, so we've got time for one more question, and then we'll get back to the content.
An IAM role is generally a system, and an IAM user is usually a person.
Okay, I lied. We have one more, and I've got a quick answer for it.
If it could take 2 weeks, and some hacks have actually taken years. It depends on how well your systems are. It depends on your security event logging and monitoring. 90% of most companies don't even know they've got someone in their systems. We install tripwires and hashing file things. It takes a long time for many organizations, as poorly done as their security is, to identify things. Now, a well-run system will be able to identify it much quicker. For example, if you're using AWS WAF, when you get hacked, you get hacked. But if you're using a next-generation firewall like a Palo Alto, when something goes on, the firewall adapts to it. So it's really dependent upon the way you write your policies, what kind of IDS, IPS systems you're using, what kind of security event monitoring and logging you're using. There's so many things to deal with in security. Way above, anything we could ever cover in a certification. But hackers can be in your systems for a long time. I think the hackers ran Azure for months before even Microsoft even noticed about it with their, Cosmos DB hack. But it was a long time. I don't exactly details. I don't remember. Let's go back to the content then. Now let's talk about a cross-account role. Actually, before we do, everybody give me a hashtag. AWS Certified Solution Architect Associate, so I know you are awake, alert, and oriented. Now, a cross-account role enables you to access another account, meaning you're in my account and I'm connected to somebody else's account. A cross-account role would enable me to do this. So Chris over there has his own AWS VPC. No, he doesn't, because we're running an OpenStack cloud. It was much cheaper for us based on our business, but for other things it wouldn't be. But if Chris has his VPC and I have my VPC and I want to access something on his VPC, I would get a cross-account role. Now it's often set up to allow a user in one AWS account access to an account that they don't own. So when you're connecting or creating a cross-account, meaning you're allowing somebody else into your account, and they're not part of your company, now you got to get scary good when it actually comes to the security. So, Super Chow or Chris, they're part of my company. They have pretty much full admin rights to anything they need to. But if it was somebody else that I was dealing with, perhaps I had an adjunct instructor from some other company, and I only wanted them access to Tuesday's class material. With a cross-account role, I would only give them access to Tuesday's class material, not everything, because with a cross-account role, remember, you're bringing in other people that are not part of your company into your business. So that need to know, that principle of least privilege becomes critical. So give access to only what's needed and nothing else. So while it's always essential to use the principle of least privilege, with a cross-account role, it is critical. Now, cross-account roles, when we're dealing with cross-account roles, an external ID is needed. Now, this external ID is going to be uniquely associated with the role. The external ID can be a secret identifier that is only known by a third party, for example. But when you use this cross-account role, you must specify this ID when you define a trust policy. The third party obviously will provide this ID when somebody assumes the role. Permissions needed by the third party are obviously necessary to work with your AWS account. So let's graphically look at a cross-account role real quick. Here you can see company A, company B, and company C. they're all allowed into my virtual private cloud, which I like to call my virtual private data center. And by using this, each one gets access to privilege. So I kind of like to view it that way. How cross-accounts roles will work. A role is going to be created for your external user. The external user is going to connect to the AWS Secure Token Service and get a temporary token. And when the external user wants to access it, we'll provide that temporary token. Now, that's one of the more complicated roles we'll get into. Now, let's get into a much simpler role, a service role, which everybody else calls a service account, but AWS calls a service role. And this is a role taken by a virtual machine called an EC2 instance that can access with another service. Effectively, it's enabling your applications to make secure API calls. So think of it this way. You've got an EC2 instance that wants to post messages into an SQS queue. You've got a system that wants to access something in an S3 bucket. You've got your EC2 instance that wants to access one of your relational databases. Now we're dealing with this service role. So let's graphically look at this real quick. Here we go. EC2 instance wants to access the proprietary Amazon NoSQL database DynamoDB. And we create an EC2 service roles. Pretty simple. Now let's talk about how you create a policy, an IAM policy. The IAM policy is going to determine who and what can access what systems or resources. In this policy, you can assign permissions to specific resources or all resources. And when you provide access to specific resources, you're using the Amazon resource name. That way you get real granular and specific access this, but not access that, which is fantastic. Now, many of you guys are fully familiar with regular expressions or Boolean things. And if we want access to everything, we can just use that asterisk, that wildcard, just like you would in a regular expression with BGP or many other things, with Linux. Now, there's going to be two kinds of policies, two main types of policies, an AWS managed policy and a customer managed policy. Let's talk about the two of them. A customer managed policy means you make it yourself. And an AWS managed policy means you take it from them. So let's talk about how we're going to create a policy under either case. We're going to sign into the AWS IAM console. In the navigation pane, we're going to choose policies. And we can create our own, or we can use one that's made by AWS. And let's think about why. Most of us are not JSON programmers. And if we're not JSON programmers, AWS has a million kind of policies, I'm exaggerating the number, but a lot. And they work for 90% of use cases. So we can basically create our own policies, or we can use the ones from AWS. Now, our policies are not visible outside of our organization. Keep that in the back of your mind. Now, if we create a customer managed policy, let's talk about how we do it. One is we could take one of the AWS managed policies, for example, and tune it. That works. Two is we can use something called the policy generator, which I'll show you what that looks like in a minute. And that basically is going to ask you some questions. And in the questions, you'll fill it in like an interview. And it's going to generate a policy for you, which we kind of like. Or you can create one from scratch. But don't create a JSON policy from scratch unless you understand JSON grammar and syntax. So this is perfect for someone with some JSON programming experience. So let's look at, what is this policy generator? You go to the AWS web page and you put in your information for a policy. It's going to ask you some questions and you'll fill in the questions and you're going to get something that's going to help you. Now, what do these policies actually look like? Well, here's an example. Remember I talked about the action, effect, or allow. So here in case we're going to allow an EC2 instance to attach a volume and detach a volume. And we specified a resource by the Amazon resource locator name. You can see that that's over there. We've highlighted this and we specified some optional conditions over here. So now that we've created a policy, We have to apply them somehow. Now, we could have created a policy for the user, like I talked about. Mike's allowed to do this. Chris is allowed to do this. Tal's allowed to do this. Alonzo's allowed to do this. Cindy's allowed to do this. Leo's allowed to do this. Manuel is allowed to do this. Eddie can do this. Anselm can do this. We could do that, or we could create a group and put those users in similar jobs into the same group. So let's talk about how we apply them. In most cases, here we go. We create an account, right? That's us. And then we communicate by, we block our group people into groups. Our network admins or our cloud admins are put in one group. They have a certain set of privileges. Our software developers are put into another group. Our test engineers are put into another group. And each one gets access to different policies. Now, how else do we further secure identity and access management? Well, we use multi-factor authentication, which can greatly increase your IAM effectiveness. And this way, if you use the username Mike and the password cat, which would be insanity, and at least it reaches out to you and asks for a one-time password, you're better off because the password cat will be instantly copied by anybody in a second and a half. But what won't be compromised is that one-time password. So the key is to use a good, really strong password and then use a multi-factor authentication. And multi-factor authentication is not new. We've been using it forever. We used to have this thing called the MAC card, money access card. It got renamed into an ATM card. I think that's what they call it now, where you put your card in, you enter your password. I still call it a MAC card because I've been around too long. You enter your PIN number, and all of a sudden money comes out of the machine. That comes out of your bank account. Something you have, something you know. You may have seen some RSA secure ID cards that people have had for the last couple of years. Again, something you have and something you know. Kind of keep that in the back of your mind. So kind of keep these things in your mind. You know, that's the concept, something you have, something you know. It's not new. Keith sold MAC cards. Yes, Keith, I could see you doing that. I knew you would remember MAC cards with me. Love that, money access cards. I still think it was much simpler when it was the blue MAC card than before they turned into these Visa things and credit card things, debit things. MAC cards were so much easier. So, you know, so how does it work? The organization sets up an authenticator app, which is basically a device with a key. The authenticator device will create a one-time password which changes every few seconds, like an RSA secure ID key. When the user logs in with their username and password, AWS will provide a challenge asking for a one-time password. And if the user provides the correct one-time password, they're authenticated. Maybe you guys have the Google app on your phone or use the old RSA secure IDs. Key is something you have and something you know. Let's look at multi-factor authentication in action, because I always love multi-factor authentication, something you have and something you know. Here we go. We got the user Billy Bob who logs into the system. Now the system says, hey, Billy Bob, what's the special one-time password you have? Billy Bob provides that user and he's allowed in. Now next, we got somebody bad. Call it Joey that's impersonating Billy Bob. Now Billy Bob signs in and Joey compromised Billy Bob's password. So Joey tries to log in. And when he tries to log in and pretends to be Billy Bob, but he's really Joey, Billy Bob gets sent this one-time password request because it's sent to Billy Bob. And Billy Bob says, I didn't try to log in, doesn't provide the access, and then Joey, the bad hacker, is not allowed in. That's really why we're using, multi-factor authentication. That's why you'll notice in recent years, your banks, your phone companies, your cable companies, they've almost mandated it. It's due to the security issues. Well, let's talk a little bit about identity federations. Identity federations enable management of access of identities in a single place, like Microsoft Active Directory. And the key components of an identity federation are as following: an identity, a user, Mike. An identity store, a place where the users are stored, like Microsoft Active Directory, or Facebook, or LinkedIn, or Apple, or Amazon. And then we typically have something called an identity broker. which is an application that's going to check with the identity store and provide access to the AWS resources. So, not that complicated what we're talking about. Now I'm going to give you the complicated, ugly steps of how this works. We're going to get into the complicated, ugly steps. Here's what's going on behind the hood. The user is going to log into an identity broker using their corporate credentials. The identity provider is going to authenticate the user against an LDAP-based directory store or identity store. The identity provider will then establish a security assertion markup language token with all the required information, and it's going to submit that assertion to the identity broker. The identity broker will then call the assume role with SAML security token service API, and that's going to pass the SAML assertion to the role and for the Amazon resource to basically assume. And if the API response is successful, it's going to include AWS temporary security credentials for the associated permissions. And with the temporary credentials, the client application can perform operations on AWS resources. So why are we using identity federations? Well, why don't we just use AWS IAM? Well, scalability. Are you going to have a person log into IAM console on AWS and type all this stuff? No, that's just too much work. It's unnecessary work. So you're going to establish a trust relationship with a known identity provider. Google's a known identity provider. Amazon's a known identity provider. Facebook's a known identity provider. Apple's a known identity provider. Twitter's a known identity provider. LinkedIn. Hey, have you ever been, use Pay using your Amazon Pay account because it's pulling your information from Amazon? It's really the same thing we're talking about here. No different. And identity federations can enable organizations to connect their AWS VPC to internal identity management applications, most likely Active Directory or some kind of an LDAP directory. AWS IAM functions are connected to the identity provider. When a user attempts authentication, the request is passed to the identity provider. The user will get their IAM authentications and receive their privileges based upon the job role, organizational cost center, and so many other providers. And this enables singular and granular control of your users. All right, thankfully we got through that. I know that's a little bit ugly, but it's definitely something you need to know. And there's some questions going on with regards to networking in the chat box. They're not exactly correct. If there's some networking questions, we'll answer that at the next time we actually get through things. Let's talk about single sign-on. When we're dealing with single sign-on, it's really an authentication method that enables users to securely authenticate with multiple applications and websites. So normally, it used to be you'd log into your systems, and when you'd log into your systems, you'd have to then log into the next site, the next site, the next site. And then maybe you noticed a couple of years ago, things got a little smoother. You logged into your systems once, and then you had access to everything. That's single sign-on. And single sign-on is a service that allows your users to sign into one place and then access resources in your account. So instead of logging into every system, you log into one. It's typically used in a federated environment, and it integrates with Active Directory, Azure Active Directory, Salesforce, and other identity providers. It basically enables your user to authenticate once, and they don't have to authenticate again and again and again. When they authenticate once, their privilege is determined and their roles are assumed. Going back to this environment, you can see what's going on. We've got an on-premise Microsoft Active Directory server, which is then accessed or connected via direct connection or VPN, which provides network layer reachability and communication between that and the AWS single sign-on app. And by logging in that way, users can access everything. They don't need to log into S3, they don't need to log into DynamoDB, and they sure don't need to log into the EC2 instance. Identity federations. Amazon Cognito is a great service that provides authentication, authorization, and user management for web and mobile apps. It provides a means to connect to identity providers, Cognito enables organizations to synchronize identity management and data across multiple devices. Cognito users can basically sign in using a directory like username and password with a third-party provider such as Facebook or Google. And the way it works is a user or app authenticates against Cognito and gets a token. The token is then used to provide access to AWS resources. Visually, graphically, I'll show you what that looks like. Got a user that logs in and gets a token. They then trade their token for credentials. And then they then use those credentials to access whatever services that they've been assigned. That's really what's going on. We're dealing with identity federations with Cognito. Now, when we deal with Cognito, we're dealing with the concepts of user pools and identity pools. And a user pool is a secure directory within Cognito that enables you to manage users in one place. That happens upon successful authentication. Cognito will issue a temporary set of tokens, also called a JSON, which is really a JSON token. A little bit more about Amazon Cognito identity pools. Amazon Cognito identity pools provide temporary AWS credentials. Cognito identity pools work with authenticated and unauthenticated identities, and Cognito can work with guests, which are basically unauthenticated users and authenticated users who have received the token. A little more about Cognito. The way Cognito user pools work is the user logs into the identity provider, and after they've been authenticated by the identity provider, basically they get a session key for the user. Then what will happen is this, using the session key, the application will place a call to the Amazon Cognito GetID API, and it's going to get an identifier for the user. And then what will happen is Cognito will validate the session key from the login provider. And if the session key is valid, it'll get an API, GetID API, and return that for the user. The user will then send the unique key, identity, to Cognito. Cognito will validate the session key against the identity provider. And if that key is valid, Cognito will call the AWS Secure Token Service, provide a token. And of course, Cognito will return a temporary token to the application so they can access the users. Now, next thing we're going to talk about is the directory service. Directory service provides a hosted dedicated service for Windows Active Directory servers, basically Windows AD servers. So you could manage yours like most businesses would, or you can use the AWS pre-managed services for you. Either case is your option. Basically, they're theoretically high availability servers that are in 2 availability zones by default. And, Microsoft AD is necessary for the most part for Microsoft Direct-based workloads. So you can either maintain your own and federate that to AWS and not have to worry about any of their stuff. And that way you can use your same AD servers in AWS, Azure, Google, in your data center and never have a problem. Or you can use the AWS pre-managed ones for you. It's your choice based upon what your business needs are, what your goals are, your availability requirements. And they're basically hosted servers that can be used by any of your systems, your EC2 instances, your relational databases for Microsoft SQL Server, AWS, and computing. Now, Chris, before I get into firewalls and things like that, is it time for me to answer questions or should I keep going?
Yeah, we can do some questions.
Let's do a couple of questions. Now, when we answer these questions, understand, identity and access management is the job of a sysadmin for the most part. I've never been a sysadmin. I started with a senior engineering role and worked as an architect. So I know most of these concepts and I'll do the best I can, but I am not an IAM expert because that's not really an architect job. We use a cross account with maybe a parent company that has different stores. Well, there's a lot of ways you could do it. So, Lady Godiva, let's say I wanted to, now remember, the cloud doesn't offer you the same level of security you can get in the data center. In the data center, you can micro-segment your stuff, use different VLANs, access control lists between VLANs. We can do all kinds of cool stuff. 802.1x and mission control and things like this. So in the cloud, we might want to chop our systems into multiple VPCs. And by doing it, we could create, let's say we're a multi-division company. Let's say we make cars, we make computers, like a company called TAD in India. They do everything, from manufacturing cars to tech consulting. We might take a company like that and chop that company into multiple virtual private clouds. Now, we may want the CEO of that company to be able to access all these other organizations. So we could use a cross-account role for something like that, which would be a perfect example of when to use these things. Cross-account role is like a multi-tenant role. I don't know what you mean by that, Sid Sam. There's lots of multi-tenant things that I'm familiar with. Maybe it can be a little more clear so I can understand what you're saying. Will ABC companies VPC use the backbone network? Well, if they're going to be using the internet, they're not going to be using the backbone. So the question is, are you dealing with, well, Azure does have dark fiber run across the globe where VNet peering happens. Again, this is some open internet. Okay, so let's chop out of this. So Sid, we either have private networks or we have public networks. Inside of our private networks, we're going to have lots of routers, lots of fiber optic connections, lots of optical connections, routers and switches everywhere. An interior gateway routing protocol, we're typically going to use something like resource reservation protocol to signal lines and make sure we've got bandwidth. We're typically going to add some MPLS on top of it. And when we create, VPC peering inside of our organizations, we're not going to be using anything on the internet. We're going to be effectively creating a pseudo wire, much the same way a VPLS LAN has been created for the last 20 years. Now, if we had two different organizations that wanted to connect to each other over the internet, that would be going over the internet, which is a completely separate network. VPC peering, VNet type peering is typically done across the private network, but it could also be done across the public network based upon which regions people are in. So I need to actually understand your question because it's not very specific. It's mixing up private networks and public networks at the same time. So the question is, are you trying to deal with the same company that's both on the same cloud in the same region? In which case that would be across the private backbone. Is it between AWS and Azure, in which case it may go over the internet with a VPN? Or if we really wanted to connect something in AWS and Azure, maybe we don't use a VPN at all over the internet. Maybe we create a private line or a direct connection between them. Or maybe we connect to a SASE provider like Aviatrix to do it. So it really depends on what are your business needs, what are your performance needs, what are your latency needs, and what are your security needs. Can we say AWS security is weak and we should be using AWS Marketplace for security products? I'm not going to say that AWS security is weak, but here's the problem. If we use an AWS WAF, here's what happens. You breach us through the firewall and you've been hacked, which is a problem. Now, when we use an industrial grade enterprise firewall, like the kind of Palo Alto does, if an attack comes into the firewall's smart. It's not like WAF. It's going to look at it and say, hey, we're being attacked. Let's do something about it and adapt. So modern next generation firewalls, when they start to see something happening, they do something about it. So Mauricio, kind of like your credit card. Mauricio, I know you live in Mexico. I think you live in Mexico City. Now, Mauricio, if you went from Mexico City and then you went to Alaska and spent $10,000, and then you went to London, spent $3,000, Dubai and spent $5,000, you know what's ultimately going to happen? Your credit card company is going to call you and stop your card. Call you and stop your card. So keep that in the back of your mind. It's going to call you and stop your card. Now, what WAF does is it can't do anything. It's not adaptive. Next generation firewalls are like your credit card. They run to heuristics and analytics. And if they see something that they don't like, they'll reset a TCP connection, create an access control list on demand, and do so many things like that. Marion, please identify an identity provider, or rather an example of one. Sure. Next time you want to go log into a website and it says log in with Facebook, that's an identity provider. Log in with your Gmail account, that's an identity provider. Mauricio, if your architects don't touch the tech, why should you be doing the labs? You're confused. Well, let me explain this very clearly. Let's say you were designing, let's say this is a hammer. If I taught you how to be a construction worker and use a hammer, a nail gun, etc., it's not going to teach you anything about how to design a hotel. So the reality is, for most architects, the only reason to ever do the labs is so you can tell somebody you did it. Because doing labs does not teach you how to design anything, and it sure doesn't teach you how to sell anything. How to sell anything is what is the tech, how does the tech work, and how does it improve a business's performance, and how do you apply the pieces together? How to configure the tech is completely irrelevant for the architect. And that's why, we've interviewed 1,000 AWS certified people from people that learn by doing courses, and none of them know architecture. But somewhere along the line, you still want to know what it works like. And somewhere along, someone is going to say, have you ever touched the tech? And the answer is you want to be able to say yes. And, if you lie, it's going to be readable. So you do the labs to say you've done it from the past. That's the only reason you do the labs as an architect. Can I elaborate on Cognito? Cognito is basically a way to work with identity as a service to provide authentication, authorization, and accounting for mobile apps. It's a means to connect to identity providers. So I'm going to leave it at that. I'm not a sysadmin. I'm not Mr. AAA. Okay, why don't we get back to the content and we'll talk about some firewall stuff where we're starting to get into the fun of security. Now we're going to talk about AWS WAF, and there are times where AWS WAF is perfect. AWS WAF has a fine, traditional non-next generation firewall, and it protects against common attacks. Typically, your man-in-the-middle attacks, your DDoS injection attacks, your SQL injection kind of attacks, cross-site scripting attacks. It's a fine basic firewall. And for a small business that doesn't have a lot of critical requirements, it's completely fine. Your developers can customize a rule to block or monitor web requests, and it's a totally fine, generic, basic web application firewall. The only problem is it doesn't adapt. Now, in reality, you're going to be using two clouds, and the second you use proprietary AWS WAF, you're going to be in trouble because you're going to need the same security policy on AWS and Azure, which means you can't use any of these proprietary services. You're going to need something like a Palo Alto firewall, a Cisco firewall, a Fortinet firewall, a Checkpoint firewall, which all have much more robust security features and functionalities. But let's talk about WAF. WAF is a basic firewall that users can create rules and place limitations on which IP addresses can be reached, which protocols and port numbers can be reached. Benefits of WAF are that it's very simple. And, it basically will look at the IP addresses where they originate, the country where they originate. It can validate requests. It can look in strings that appear as requests, or the length of requests. It can look at some bad SQL code that's in a request, and it can block it. So it's really just a firewall that protects against web application attacks. It looks for common exploits. You can put it on your CloudFront distribution, which is your content delivery network, which we'll talk more about. You can put it on an API gateway or a REST API, or of course your load balancers. And it'll sort of block your connections at edge locations before they get onto your network. And there's nothing to preclude you from using WAF with a full next generation firewall as well for additional layers of security, and that's totally fine. And WAF will give you somewhat granular things. It's basically it's basically like a stateful ACL, where you create web rules and rule groups, and you're either going to permit stuff or not permit stuff, and it'll provide the ability of traffic metrics. So let me show you how they put it, and then let's do a walkthrough. The way WAF works is you're going to enable it on your device. You're going to create a policy that provides access or filters to the device. WAF will look at the policy and say good or bad, and if it's good, it'll allow the traffic through, and if not. So let's realistically look at how this works on AWS, and then let's whiteboard it out so you truly understand a firewall. Here we put WAF on our CloudFront, which is our content delivery network. We'll get into that. We'll put it on our load balancers, our API gateways. We'll set our policies and keep stuff from getting into our systems. Now, how do we combine it? For example, we'll talk about Shield, which is some DDoS protection. And basically every content delivery network gives you DDoS protection. The AWS branded one is Shield. And we can put this web application firewall. So this will keep unwanted traffic out of your systems. And then you'll keep unwanted traffic out of your subnets with the difference between an access control list. And then we'll use a security group. So realistically speaking, what are we really talking about? We're talking about this. So let's say you've got your load balancer over here. Here's your load balancer. Behind your load balancer, you've got some web servers. Obviously being a private subnet. On an additional subnet, you'll have your app servers. And if there's more than one app server, what are you going to need? You're going to need another load balancer. So let's make these things a lot smaller. Three-tier web environment. Typically, you've got a load balancer. You've got your web servers. You're going to have another load balancer. Put this over here. You'll have some app servers. And you'll typically have a database back here. And what you really want to do is before your load balancer, because this load balancer over here, if it's a web app, is going to have a public IP address. And in front of this, you're going to want to have an access control list. Actually, we're going to want to use a security group before we get to the load balancer. So let's pop in a security group over here. And we're going to pop in a network access control list over here. And in front of this network access control list, we'll have a firewall of some kind. Now, usually it'll be from the marketplace and there'll be next generation firewalls, or it could be WAF. But this is really how the pieces and parts are going to fit together. The firewall is going to keep unwanted stuff from getting into your systems, which is going to be further blocking the subnets with access control lists. And then after this, we'll have a security group protecting access to the load balancer. And then our web servers will also have a security group, but most likely we'll have an access control list between them. And then we'll have another security group for this load balancer and vice versa. So that's typically the way that we tie the pieces together. Now, the next thing we're going to talk about is preventing DDoS attacks. And let me tell you, when it comes to preventing DDoS attacks, we're actually dealing with a lot of things. So there's no one thing that protects against DDoS. You know, just adding a firewall, 2 next generation firewalls fronted by more next generation firewalls fronted by IDS IPS systems, that's not going to stop it. It takes a lot of work to stop a DDoS attack. So let's talk about what a DDoS attack is. A distributed denial of service attack. I want to make sure you guys understand this. So let's say over here we've got a web application, okay? And let's say this web application, which is on the right side of the system, can handle 100,000 web requests per second. 100,000 web requests. So it's a big, big, big server, lots of servers. Now, normally we've got 50,000 web requests. The server can handle 100,000. Life is good. Now, where does it break? There's a DDoS attack that can happen by accident. Let's say the company says Christmas sale 80% off, and they get hit with 300,000 web requests when their server can only handle 1,000. The company effectively DDoS themselves by taking in more requests than the web server can handle. The web server rate crashes, and that's a DDoS attack. But that's when organizations make mistakes. Let's talk about the more traditional DDoS attack, which is what goes going on here. And these DDoS attacks are getting big, big, and even bigger. In a DDoS attack, you got a hacker as specified by this red guy over there that looks real mean. The hacker has his server or her server and uses that server to hack into 20, 30, 40, 100,000 servers on the internet. And then those servers are used to create web requests for the web application. So the server can handle 100,000 web requests. We now control 100,000 servers, and each one of those 100,000 servers does 50,000 web requests per second. And now we can see our servers getting hit with 1 trillion web requests when it can only handle 100,000. The server crashes, potentially buffers are overflowed in that server. Maybe people get inside of our systems, or else they just shut us down. So all a DDoS attack is using multiple servers to completely overload your systems. And there's a lot of things that can go into preventing these DDoS attacks or improving them. Take this web application that could handle 100,000 web requests. Now, if it was in an auto-scaling group and it could then auto-scale out to 15,000 servers, well, that could help the organization mitigate the DDoS attack. Maybe the DDoS attack can be blocked by the firewall. Maybe it can be blocked by the content delivery network. There's lots of things that get involved in mitigating a DDoS attack. It's not just one thing. It's not just one thing. So let's talk about preventing DDoS attacks. When it comes to preventing a DDoS attack, we're talking about a full security posture. We're blocking unwanted traffic out of subnets with regards to ACLs. We're keeping unwanted traffic out of servers with security groups. I talked about auto-scaling and how we can do that. Firewalls will keep unwanted traffic, and WAF can help. Now, typically speaking, here's where we can make a big difference, and it's on our content delivery network. See, the content delivery networks will only forward legitimate web requests to a server. And one of the ways you kill a web server with a DDoS attack is you send an overwhelming number of half-open TCP connections, for example, requiring the server to open up, and they never close these connections because they're waiting on something. So by using a content delivery network, the content delivery network can recognize the web requests being bad, which is usually bad requests in a DDoS attack, and they don't let them go to the server anyway. So there's lots of wonderful content delivery networks out there, and they all have some massive DDoS protection, whether it's the Akamai, which is kind of the king and queen for most people that consider of content delivery networks, or whether it's Cloudflare, or whether it's AWS CloudFront, or the Microsoft CDN, or the Google CDN. There's lots of content delivery networks out there. So when you have a content delivery network, they enable you to put some DDoS protection. And you put the DDoS protection on the content delivery network. And that DDoS protection will not forward the requests to the systems. They'll recognize problems, and they'll block them. Now, every content delivery network provider has a DDoS attack, a DDoS prevention system, and AWS has quite a good one for their content delivery network. They use Shield. Shield is the AWS branded DDoS prevention service. And Shield Standard provides very basic DDoS protection. It's about as basic as AWS WAF, but it comes free if you're using WAF. And then there's Shield Advanced. Now, Shield Advanced is much better. Shield Advanced you can put on your EC2 instances, your load balancers, your CloudFront, your DNS, global accelerators, and it does a lot more. So when you're using Shield Standard, it's free, and it's going to protect you against the most common attacks. AWS says 96% of attacks. That's what they say. It protects against your main things, your SYNAC floods, your reflection attacks, your HDFS slow read, but it works based upon a policy, and it's static. And I hate static when it comes to security. It's not good enough, and here's why it's not good enough. Once you've been hacked, you've been hacked. You've been hacked. You've been hacked. Great. No adaption, you're still getting hacked. Now, you've got better option with regards to your DDoS protection on AWS. You can use Shield Advanced. And now we're starting to get in the range of good DDoS protection. Now, of course, you're going to pay for this, and it's an additional cost. And you provide this protection in your load balancers, your virtual machines, CloudFront, Route 53. And now we've got intelligent attack mitigation. So now you've been hacked, and now Shield says, I don't like this, and it's going to stop the attack. Kind of like the way Pac-Man would eat the dots on a video game. I know Keith West remembers Pac-Man and a few others do, but not everybody. So kind of keep that about with what you're dealing with. This is what we're going on with regards to DDoS, and this is what we're dealing with Shield Advanced. Shield Advanced will look at traffic patterns, deploy an ACL to mitigate the attack, for example. It allows visibility into your notification layers for 3, 4, and 7. And AWS Shield Advanced customers have access to 24/7 DDoS people, assuming they're using business or enterprise support options. Now, because some of these solutions are kind of weak, and security takes a ton of other things, there's some other things that you can use. Some AWS proprietary security services include GuardDuty, which is a service to monitor your AWS accounts, and it'll look at your CloudTrail logs, DNS, VPC flow logs, and it'll look for patterns of behavior with compromised systems, and it'll send you a notification, hey, something doesn't look right. So you can use systems like this. There are also industrial grade systems, SIEM systems that really do this and do this really well. Big industrial quality systems that you can use the same systems across multiple clouds. While we're at it, you've got something called Amazon Inspector, which is a security assessment service that helps improve your security posture and compliance of applications. It looks and constantly assesses for applications exposure, vulnerabilities, etc. And after performing an assessment, it produces a detailed list of findings, and then it'll give you some recommendations. Again, automated services are automated services, which are automated services. They're no substitute for having professionals look and see what's going on. You also have Amazon Macie, which is a fully managed data security and privacy service that uses machine learning and pattern recognition technology to protect your data. It's going to look for your S3 buckets and unencrypted buckets and publicly accessible buckets, and it's going to make some recommendations. And Macie will apply machine learning, for example, and pattern matching techniques to identify you with an alert. Of course, there's many better things that you can do. You can find things that are notified and create some event-driven security with some Lambda functions to go fix this. But these are basically services that are designed to assist you. Let's look a little bit about the service catalog. Now, this is pretty good stuff here. Pretty good stuff. Now, what we're actually dealing with is, when I was a little boy, a little bear, getting into networking, and I was a young kid, they called me Sniffer Boy. Why was I Sniffer Boy? I was plugging in the sniffer or protocol analyzer, and I'd find, hey, wait, this person opened up the firewall so they can use Napster. This one was downloading the entire internet library of porn. This one opened up a port on the firewall so they could do stuff. And we would find systems that were vulnerable. People would put their FTP servers on the network or their client servers on the network, and we'd get hacked because of other people and the things they did. We'd have systems that weren't properly patched. Joey's stuff was out there. It didn't comply to security policy. And we had the sniffer boy me that was running around trying to figure out what the traffic was on the network. Now, in those days, it was pretty hard to lock down your systems. Now, in today's world, we can use the service catalog. Talk about a great service. The service catalog can help you control what's placed on your systems and make sure they adhere to an organization's security policy. Now, this is good stuff. The service catalog will help you control what's placed on the network. This is really, really good stuff. So what happens is you create a list of approved things, approved virtual machines, approved servers, approved software, approved databases, approved application architectures, anything. And you pop them in the service catalog. And you only allow systems admin people to use stuff directly out of the service catalog. So this is why I love this stuff. So the user can access something in the catalog. They can deploy it with an infrastructure as code strip. And poof, it'll automatically deploy your things. And you're sure that they guarantee with security policy. And here's why. You've already approved them ahead of time. This is one of these transformational things in the cloud. Infrastructure as code, deploy things practically at the speed of light, and make sure they're exactly what you need. So there's some real digital transformation here. This is excellent. talk about some more security services. And I hope you're gathering that security is about using a lot of tools from a lot of people. Some of these great AWS tools, some tools from Microsoft, some tools from the security vendors, some tools from identity people. It's a combination of everything. It's like an onion where you keep pulling back the onion. Let's talk about the Systems Manager Parameter Store, another very cool security service. And it's a key component of a strong security posture because a lot of things that we have to deal with are licenses, password strings, database strings, and it's probably not good for you to have sticky notes all over your desktop with everybody's password. I've seen it. I know Keith West has seen it, and I know Chris has seen it. I know many other people have seen it, like Alonzo. I'm sure he's seen that too. Some of the younger people may not have seen that. And what we're dealing with here is if your information is compromised, like a password, it could be a bit of a problem. And AWS provides a solution for securely storing your secret information. That's called the Systems Manager Parameter Store. I don't know how they make up that name, but it's a good service. Now, the Systems Manager Parameter Store is a scalable, hosted, serverless environment that's designed to store your passwords, database strings, license codes, and API keys. To kind of keep that in the back of your mind. If you've got extremely sensitive information, stick it in the Systems Manager Parameter Store. It provides a means to store and encrypt your encrypted data. And it's a great way to store and manage your instance receipts. It's going to separate your code from your passwords. It's going to provide an excellent means to audit access. And it's going to provide a method for you to track your password use. Let's talk about some more AWS security services, the Security Hub, which is a service that provides users with a broad scope or extensive view of user security posture and facilitates AWS environment's compliance with industry standards. Okay. It simplifies how users understand and improve their cloud security posture with automated security best practices checks by collecting, prioritizing, and securing data across accounts. Automated system, make sure you got real security people that understand how to do real security. And this is informational that they can use to give them additional information in addition to the other things that you may need to be doing. Provides a central view of security and compliance posturing. The AWS Security Hub is an aggregated and analytical tool that works across AWS Services accounts and some third-party tools. That's the key, some third-party tools. This tool tracks data against best practices and standards to identify oversights. Look, there are really good tools that you can use out there that are not proprietary, that work with everything, that are going to work on all your things. But if you only had a customer and they were only on AWS and they had a small budget and they were using only AWS services and they didn't have a lot of security, things like this are excellent because they give you additional information. Let's talk about the Firewall Manager. It's a security management service that allows users to essentially run up and control their WAF, their shield, security groups, and to some degree, some third-party marketplace firewalls. It ensures new users and applications can be operated automatically under procedures. Basically, an administrator can apply a rule across an entire organization and limit policies to a single group, users, or specific applications. Users basically set up their projections once, and the service automatically applies new things to your accounts and resources. Firewall Manager can basically be used by companies that are operating in a highly regulated environment to say you've got some stuff and you're doing some analysis. Service integrates with WAF rules to protect things. Can also be used to automatically patch and protect systems. Like when you're dealing with next generation firewalls, many of them have their own platform that can be used to manage across multiple clouds all at the same time. And when it comes to availability and performance, 1 is none, 2 is 1, and 3 is greater than 2. A single cloud, no matter how many regions and availability zones you use, there's a single point of failure because the control plane goes, the cloud is dead, the cloud gets hacked, the cloud can die. If there's a serious network issue, the cloud can be down. So there's lots of systems that you can use across platforms to really do this. Now we're going to get next into the AWS applications and services, which has got some really cool stuff, by the way. So at this point, let's take some questions for about 5 to 10 minutes, or maybe 10 minutes, and then we'll go into the next section. AWS WAF works at layer 7. Yeah, sort of it does. But you're also going to be creating firewall rules, so it'll give you some other layer 3 or 4 stuff too. Chris, you can go to the next one. No, one can equate a next generation firewall as security for the entire hotel, perimeter, etc. Whereas WAF has security to get into a room. No, I'd kind of look at it this way. I would look at it this way, that WAF is the security guards outside your system, keeping people from getting into the hotel. They have basic training and can stop common things. And, if anything serious gets in, they just get in and you're done. I would view a next generation firewall as having some SAS commandos, Navy SEALs, or Israeli commandos at the door that are fully armed. And normally they just do security stuff. Someone comes in, they're not supposed to be there, they say leave. Come in, you're not supposed to be there, say leave. Then all of a sudden you got a bad actor that comes in where the security cards would normally run in hard, and your Navy SEALs shoot the bad actor. So a next generation firewall is basically something that can do something about it, something that can adapt, and something that's strong. And I would use WAF as something that's just generally there, like a basic security guard versus a Navy SEAL. In the DDoS attack, is the server real, or could they use their own PC, or are they accessing server somewhere else? Well, if it's a DDoS attack, if it's a denial of service attack, they can just use their PC. But if it's a distributed denial of service attack, what they're doing is they're compromising many servers, and that's why it's distributed. So they're going to use their server to potentially access 1,000 servers and then launch an attack with you that way. Big, massive attack. Can we shift DDoS attack log analytics to specific sequence like Splunk? That's not going to get you. By the time you do that, you're going to have been hacked, and you've been hacked for so many weeks and months, and you're not going to know it. You're going to be using intelligent SIEM systems because, look, your next generation firewalls, which you're going to be using, are going to be giving you logs. Most organizations that require critical security are going to use 2 sets of next generation firewalls from 2 different vendors. They may also use a network-based IDS, IPS system, intrusion detection, intrusion prevention system, and that's going to give them logs. Then we're going to get VPC flow logs. Then we're going to get logs from our access lists and our security groups. Then we're going to get logs from every system that we actually have. And we're going to get identity and access management logs. We may potentially put those logs in an object storage. We may actually use a Python script to manipulate those logs. We can even run a machine learning engine on our logs to try and visualize it and use a visualization tool like Tabulo. But we're not going to be shipping off to other people, things like that. We're going to be doing it on our own. And some of these DDoS attacks get really, really big. So we're going to need some machine learning. And we can do it on our own. We don't need to outsource to other companies. Is Shield placed in a CDN? Shield is usually placed in a CDN, but it can also be placed on load balancers and other places as well. Systems Manager Parameter Store is where you store your secret keys. I didn't mention Secrets Manager. Some of these names, I don't know who mixed them up. Anything else, Chris? Is it possible to stop an attack by blocking a particular range of IP addresses? Godson, sometimes you only have to block one attack. Sometimes you have to block a range of IP addresses. Sometimes that's not enough. It depends on the attack, and that's why it takes, firewalls, IDS, IPS systems, access control lists, security groups, identity and access management, encryption strategies, locking down your servers, disabling things on your servers like unnecessary ports being open, host-based firewalls, host-based IDS, IPS system, patching systems. There's so much that goes on to it. Once you understand, a great cloud architect wouldn't rely on a single cloud, and therefore, from a security perspective, shouldn't use proprietary systems. Yeah, no, I wouldn't use most of these systems in a security thing. I would use big industrial things that I could put all on the same cloud. Good thinking, Mauricio. But This is an AWS Certified Solution Architect Associate exhaust, which really has nothing to do with the job of being an actual solutions architect or a cloud architect, but it's related to a certification, so we must cover those things around the certification. There are certain things that we would use, like the Systems Manager parameter. That is amazing, and we should be using that equivalent everywhere. And then there's some things that we might not want to use, like WAF. We might need to use the next generation firewall instead. For HIPAA clients, should you enable API gateway logs? Look, for HIPAA compliance, you're going to need a whole lot more than that. HIPAA compliance is related to the HIPAA laws, which is basically related to saying that people that have a business relationship are allowed to receive patients' information, and those that don't are not. For example, let's say I'm practicing internal medicine, something I'm pretty familiar with. If I send that patient to a cardiologist for a consult, that cardiologist has a right to know about my patient, and I can share my patient's information. Now, if I come home from work that day, and my wife is practicing internal medicine that day, and she's not involved in my patient's care, I can say, "Hi, wife, how are you today? Let me tell you about my patient," because that would be breaking patient confidentiality. So HIPAA is more related to that, which systems are allowed to talk to whom, which systems are allowed to share information, and it really has nothing to do with these logs. You do have to log what happened in a different manner. How often you recalibrate your security layers? We are constantly looking at our security, constantly analyzing, and constantly tuning, constantly. As a solutions architect, how do you know when to use on-prem, cloud provider, third party? How do you solve this? That's why you're risking the unknowns. That's why you're trained as a solution architect. That's why we have 500 hours of training in our cloud architect career development program, because it really takes us 500 hours of training. We take about 50,000 pages of reading and knock it down into 500 hours of training. And because I've been an architect for 25 years, I know how to guide my students this. That's why, with architect training, like, you can get an architect job as your first job, and you can see a list of videos on our channel. But if you were just getting certifications, then people would want you to get years and years of experience, and they'd hope you'd gain this wisdom along the way. I'm going to tell you this right now. Years and years of doing other people's job doesn't teach you how to be an architect anyway. But that's why you really need to know this. And what is the most critical skill for the architect? Communication skills. Because you got to ask your customer, tell me what's going on in your business pain points, your business goals, business strategy. And then when you leave that customer, you go back to your own organization, and you got to go build a team of the 40 or 50 people that you're going to collaborate with to design the architecture. Then you got to go document this thing, present it back, and sell it to them. And that's why the sales skills, the leadership skills, the communication skills, the executive presence all matters, not your ability to configure something. Good questions. So actually, give me a hashtag AWS Certified Solution Architect Associate. And no, we are not salespeople. We help sell the product. The salesperson does the sales, and we help sell the product along with them. We are tied to the sales executive. Basically, they'll sell anything, and we're supposed to be the people that know what we're selling to make sure that we sell the thing that's the right thing to help solve those business person's problem. So please give me a hashtag AWS Certified Solutions Architect Associate so I know you're awake, alert, and oriented. Keith, no acronyms. Full word. And I know you know. In fact, in my course, I think I'm going to have a swear jar. Anytime somebody uses an acronym, they owe $20 in the swear jar, and we'll donate it to charity, because acronyms create communication nightmares, and we don't want to use acronyms as architects. Tyrone, we're going to have to get you into that swear jar as well. And Tyrone, you're pretty solid and rock star. I know who you are. Okay, let's get involved into AWS services. We're first going to start with SQS, or Simple Queue Service. Now, this is a wonderful proprietary queuing system. In a multi-cloud environment, you would not use this. You would use Apache Kafka. But here's what we're dealing with. It's a message queuing service that provides temporary message storage. I love this. Now, queuing systems enhance application availability by providing a means to store and keep messages from being lost. Now, the standard SQS queue, you typically think of it being used in a database, and we'll get back to that in a minute. And it's going to be used for transient storage. In fact, the default queue retention time is 4 days, but it can be configured for up to 14 days. SQS or any queuing system enables right sizing of your applications. It'll facilitate auto scaling, and SQS mitigates the need for middleware messaging systems and multi-tiered applications. So what is it? It's an AWS proprietary queuing system. It's typically high availability. It scales well. And the whole point of it is to decouple your system's environments. Simple queuing system will help you decouple your environments. And let me show you exactly what we're talking about. Let's say in this environment, for example, we have a web server and a sale comes in, right? It hits the app server. We temporarily hold the message and the Amazon SQS server until the database is ready to receive it. So web server, app server, queue on the way to the database. Now, the reason we're doing this, if the database was full, we'd be losing the messages. But if it's in a queue and the database is down for 30 seconds, it's no big deal. We're all kinds of happy, right? And the reason we're all kinds of happy is as follows. The message is still stuck in the queue. So queuing enables right sizing of our systems. Now, in this case, DynamoDB is serverless, but let's pretend it was a server-based database. What if all these messages comes in at one time? And then no messages come in for a half an hour? That's pretty normal. Things aren't like slow and fast. There are all kinds of weird patterns of traffic. So queuing enables you to smooth systems out and have the exact right size. So we're dealing with queues. We're going to have the option for standard queues and FIFO queues. A standard queue is this. As fast as the stuff enters, it leaves. Every message is going to be delivered once. Best for delivery. Now, what if we had an application that needed something specific? We'd be dealing with a first in and a first out queue. Now, in this particular way, message 1 gets delivered before message 2, which gets delivered before message 3, which gets delivered before message 4. Now, this is going to slow it down. And the reason it's going to slow it down is, what if message 1 is big and message 2, 3, and 4 are slow? 2, 3, and 4 will wait for message 1 to be delivered. But it really doesn't matter. What we're really talking about is as follows. We're talking about what's based for the application. Let's talk about the next thing called the dead letter queue. Message comes in, doesn't make it into the database, and we store it so we can go back and take action on it later. Kind of like the mail. Ever notice the mail it gets delivered to you, you send it back, and they store it somewhere? It's called the dead letter queue. So how does queuing work? Messages are sent from the computer to the queue. They're held into the queue. As soon as the receiver can take it, the messages are drained from the queue, and then new messages can come in. I showed you this before on the first day when we talked about databases, but I want to show it to you again. Here we've got in the same queuing system, messages come in, they're stored in the queue, they're drained from the queue if and when necessary, and then they're given to the receiver. So when would you use SQS? Well, if you're using a single cloud, you would use SQS. If you're using multi-clouds, you would use Apache Kafka. But you would use SQS to assist with capacity planning and application scalability to make sure messages are not lost. Messages meaning orders, usually as it relates to sale, as opposed to systems being overloaded. SQS is fantastic for cost optimization because instead of having to purchase your servers for their maximum capacity they might read, we can base upon an average capacity and store those messages inside of a queue. And SQS can be very effective for auto scaling with its ability to provide a trigger. So for example, you could have messages in a queue of a certain thing, of a certain idea. When the messages are in the queue, you could say add compute capacity if it's necessary. So kind of keep that in the back of your mind. And it can help you handle spikes on platforms without having the scaler make changes to the platform. SQS is good for handling, what are we talking about? Increased traffic and write capacity. Second, guys. Now let's talk about message queue. Amazon Message Queue is a fully managed open source message queue, message broker type service. Kind of like Apache Message Queue or RabbitMQ. It's a fully managed service for that. Amazon Message Queue makes it easy to set up and operate message brokers in the cloud, so your users can mitigate messaging and applications without rewriting their code. Enterprise level customers could benefit the most from using Message Queue because they no longer have to re-engineer applications to use SQS. Of course, if they are using Rabbit Message Queue and they had their own systems on a virtual machine, they could just migrate them to the cloud and have the same things on all three clouds and not worry about it. But this is a proprietary Amazon managed service. But managed means you don't have to worry about the systems, the virtual machines. Enterprise level customers can use it because they don't have to re-engineer things, but they didn't have to re-engineer things anyway by moving the virtual machines. But because Amazon's managing it, you don't have to manage the maintenance, security, updates, monitoring, and troubleshooting of the message queue. Amazon Message Queue gives pay-as-you-go pricing, meaning users pay for what they use. Every time the message broker instance runs, the system is used. Storage is billed monthly, though. And AWS will calculate the number of gigabytes that are used each hour, and it'll divide it by the number of hours in each month. And the result will be a value of gigabyte months with data transfer fees charged separately. Now let's talk about SNS. SNS, or Simple Notification Service. It's a managed messaging service used to deliver message between systems and people, between systems and people. SNS is used to decouple messages between microservice applications. It can be used to send an email or a push message or a notification to mobile devices, like a message, hey, you've been hacked. Or a message that your CPU is 100%, go do something about it. SNS is great for this. SNS basically facilitates communication between senders and receivers using a publisher-subscribe model. So when you subscribe to a mailing list, for example, and you get an email, publisher-subscribe. So a publisher-subscribe messaging model enables notifications to be delivered to clients by using a push notification. You ever get a push notification from YouTube about a video? Same kind of thing with using a service like SNS. SNS will consist of two components, publishers and subscribers. The publishers send the message, the subscribers read the messages. I always like to use the term mailing list. To me, it makes sense. SNS is also used to do something called fanning out messages. What does that mean? Here we've got a publisher with a subscriber, and we send that same message to multiple systems. And we could have a single message that could be sent to SQS, which could also be sent somewhere else or somewhere else. That's the fan out. But here's the point. Publishers send to a topic. The people subscribe to the topic, and they're there. But it could also be used to fan out message. We may have a message which would then go into a message queue, as well as a notification. And then there's terrific. Kind of keep that in the back of your mind. And all kinds of stuff. Chris, I just got your message. You're going to have to tell me after this class who was hired. I'm totally excited. Every day we get a new cloud hired, and I haven't had my cloud hired yet today. So super excited. Can't wait to hear. We had 2 yesterday, so another one today. I'm thrilled. Let's talk about SNS platform functionality. Sorry, I didn't realize I was behind my slides over there. SNS is a high availability platform that by default runs across multiple availability zones. And SNS can be used to fan out messages as I described before. So basically, you've got a message that's going to a Lambda function, an SQS queue, a notification. And SNS allows you to the creation of filter policies so you only receive notifications you're interested in. That's great, right? You only want to see what you're interested in. So let's talk about some use cases for SNS. SNS can send applications and systems alert. Hey, CPU is 80%. Add more capacity. SNS can take incoming messages and send them to multiple systems at the same time. That's called fanning out. SNS can be used for mobile notifications. I love this. Imagine an application that's being pushed to realtors, for example, that's while they're driving, that says, new house for sale right now. Go show your clients. So we're dealing with some pretty exciting stuff here. Let's talk next about elastic MapReduce. So when you're dealing in a big data environment, what you're really dealing with is taking an environment where you're going to take data from one source and move it to another source. Now, in the big data environment, typically somebody writes a Python Spark script, and it's used for mapping and reduction. So, example, you may have Mike. Mike may be spelled in all capitals. Then next it may be spelled in all lowercase. Then it may have a capital M and a lowercase IKE. And that obviously would be a problem when we're analyzing the data. So we need to normalize the data. Now, normally what happens is somebody makes a Python Spark script, and they do this automatically, but AWS has a service for doing it as well. Now, if you write a Python Spark script, you can use that same script across your 3 cloud providers. But if you don't have somebody in the big data environment that's good at writing that Python Spark script, you can use the AWS pre-managed service. And that's what Elastic MapReduce is. It's an application for processing large amounts of data. It's a managed cluster and service for managing big data frameworks. And it's really a pre-built framework that's going to facilitate big data analysis and processing without the need for server management, application installation, or configuration. And it's built upon open source tools such as Apache Stark, Apache Hive, Apache Keyspaces, Apache Flink, Apache Guido, or Presto. And it typically offers some higher performance than traditional solutions. And it could be less expensive if you don't have to code it yourself. Or if you've already got your scripts, that's cheaper to use your own scripts. And that's the key, is to determine what's best for you and the organization. Now, when it comes to NoSQL databases, I mentioned previously that DynamoDB wouldn't work in a multi-cloud environment. It won't, because it's proprietary. And it's not like we can have Cosmos DB, Google Cloud Bigtable, and DynamoDB across our 3 clouds. That's not going to work. But we could use a standards-based database, like Apache Cassandra or MongoDB, across all of them. So because of this, AWS came up with Amazon Keyspaces. And it's basically a serverless, fully managed Apache Cassandra compatible database. Now, the good news with this is you can take your data straight out of your Apache Cassandra database and put it directly in here. And there's no systems to manage. Of course, if you had an Apache Cassandra database, you could just take those virtual machines, move it to the 3 clouds, and have them synchronized and not have to worry about any of this. But, this is good for organizations that don't want to manage their own systems. The service is provisionally patched for them and deployed. And because there's nothing to worry about, it can be helpful because organizations don't need as sophisticated of an IT staff. But remember, when it's serverless, you have less to worry about, which is great. But you have less customization and capabilities. So serverless is simpler, but simpler doesn't mean better. It means different. If you need max control, max performance, don't go serverless. If you need simplicity and elegance, go serverless. All based upon the business case. Like Keyspaces is a managed Apache Cassandra service. Again, excellent. So when you deal with Apache Cassandra, it's fully managed. Like I said, so there's nothing to manage, so it's much easier for you to deal with. You basically have 2 kinds of capacity and throughput modes for read and writes. On-demand mode and provision capacity mode. On-demand mode means it's basically what you think you need. And provision capacity mode is you tell it exactly, I need this much performance, and you're going to get it. Now let's talk about lake formation. If you need a data lake, there's two ways to do it. Your data architects can architect it their own way, normalize your data, and create their own data lakes, and that takes a level of sophistication. But with that level of sophistication, you get something very special. But it takes a level of sophistication. That level of sophistication gets expensive because now you need data architects, potentially even some data scientists. But if you didn't want as many of them and you wanted a simpler team, AWS has this service called Lake Formation. And Lake Formation is a managed service that facilitates the rapid deployment of a data lake. And a data lake is effectively a repository that holds large volumes of unprocessed and processed data in the same location. And this information will come from a variety of sources. Unprocessed data is going to be captured very quickly in its raw format. It'll be tagged with metadata, which will provide some information about the raw data. Conversely, processed data is going to be assigned to tables, fields, or other elements before storage. And while this will slow data capture speeds, it creates an environment that stores an unlimited amount of data in various formats. So, pretty darn awesome. Now, what happens is form these data lakes quickly and accessibly. And then we can use any kind of analytical, machine learning, or pattern matching techniques we use. See, that's the whole point of a data lake. Create all this data, store this data, and then use this data at some point in the future to make better business decisions, which can improve profitability, reduce costs, or improve information. And that's what we're talking about is actionable data. If an organization has data and they analyze that data and they mine that data, maybe they know that use this price and you're going to maximize sales. Maybe they know that at this time of the year, they don't need as many employees. Maybe they know this time of year, hire some temporary employees. The ability to make better predictions, otherwise known as inferences, is really how big data can do things. Big data can tell a customer, can tell a company their customer's desires. They might find out that I like cat things. And when they've got a new cat product, they might send me a cat email, as opposed to sending me an email every day, which is going to cause me to unsubscribe from the mailing list. So data, and more data is a really cool thing. Now let's talk about Amazon Timestream. Amazon Timestream is a fully managed, auto-scaling, distributed, fault-tolerant relational database. It uses basically, it's an SQL-based database, and the service specializes in storing and quickly tracking data variables that change over time, such as time series data, user data, IoT data, and it's capable of ingesting millions of events over a time interval from various device sensors, etc. Now let's talk about CloudWatch. CloudWatch is just an event monitoring or logging service. CloudTrail, auditing. CloudWatch, logging. Because we'll get to these and people confuse them. CloudTrail, auditing. CloudWatch, logging. It's just a log. Now, CloudWatch is a monitoring service that's going to monitor your AWS resources and applications on AWS. It's going to provide you system metrics, like CPU usage, by the way, or disk usage. It can monitor applications, give you custom metrics. So, I mean, let's look at it realistically speaking. It's just no different than logging than any other organization would have for their business. With Amazon CloudWatch, it'll collect information. You can monitor that information. You can analyze the information that you get. You can act on that information, make changes. And then you can remonitor, react, and then reanalyze until you get it right. And this is going to be a constant state of flux. It's never one thing where it's always going to be the same thing. CloudWatch can monitor a lot of things by default. It looks at CPU utilization, disk read write in terms of input and output operations per second, and network utilization. Now, that's not a lot. The default is disk I/O, CPU, and network. But if you need better logging, you can use custom metrics. Maybe you want to look at your memory utilization or your API performance or other metrics. CloudWatch also has a notification system that notifies you when things are there. Ding, 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 tell your systems administrators your systems are at 80% load. Maybe add capacity. And a CloudWatch event that sees something good or bad can then trigger auto scaling, increase your capacity, kind of cool. It can trigger a Lambda function to remediate something like that, to remediate something like, wait, it found an S3 bucket that's not doing what it's supposed to be. And then you can do something about it or act upon it. AWS CloudWatch is available in 2 versions for EC2 instances, basic monitoring. And with basic monitoring, your data is going to be available every 5 minutes, and if it's accessible to you at no charge, let me tell you, capturing your data every 5 minutes is not often enough to give you the peaks and troughs and to really see what's going on. Many times, if you really look at it, you'll see that for 3 seconds, the CPU hits 100% and you got a problem, and then it's averaging to 30%. So 5 minutes default, probably not good enough. When you use the detailed monitoring, you can get your data at least once a minute, but then you're going to pay extra for it. And detailed monitoring must be enabled on your virtual machines, otherwise known as your EC2 instances. CloudWatch events deliver a near real-time stream of system events that describe changes in your account. You can set up a rule to match events, route them per a particular function or stream. CloudWatch events will become aware of the operational changes in your system as they occur. And CloudWatch will respond to these events and changes by taking corrective action, sending messages, respond to something like activating a Lambda function. Any kind of logging you can do is always a good thing. Now, I mentioned CloudWatch does logging, and CloudTrail does auditing. So what do you think we're getting next to? CloudTrail, everybody. CloudTrail is an AWS service that assists with the auditing process. It provides an audit log that assists you with risk management. So manage your in healthcare or finance, and you need to know exactly what your people are doing. Here you go. Completely go. So that's what we're actually dealing with. You can find out who does what and tracks it. CloudTrail can track changes made to an AWS account by a user, which means a person, a role, which typically means a system or a service. When CloudTrail is enabled, is enabled automatically as soon as your AWS account is created. But then if you want to monitor, you're going to create a trail at the CloudWatch console, CLI or CloudTrail API, and it will record events, and these events are going to be visible in the CloudTrail console under your event history. Your CloudTrail event history will let you view events that have occurred in the last 90 days. Additionally, CloudTrail can be configured to store logs in an S3 bucket for long-term storage. Long-term storage, long-term logs, machine learning on your logs, analysis of your logs, HIPAA compliance on your logs, banking compliance in your logs. That's what you store them in a storage. Now, when we create a CloudTrail, we can create 2 kinds of trails. We can create a CloudTrail that is local to one region, and a one region only CloudTrail to give us the information from one region. And it's going to store the CloudWatch the CloudTrail logs in a single bucket. And this is the default option when CloudTrail is configured via the CLI or the API. By comparison, we can create a CloudTrail that applies to all regions. And this will provide the most comprehensive logging and auditing option. It'll provide a record of all events that exist inside of the organization's entire infrastructure. And this can help correlate problems across global organizations and global infrastructures. And that's the key. You may find something that happened in one part of the world and then something else that happened in another part of the world. And if you couldn't correlate the events, you wouldn't know that they were related, but in many cases they are related. All of this stuff is about event correlation. How does one thing impact something else? Okay, let's talk about CloudTrail a little more. Here you can see we've got our virtual machines, EC2, our identity and access management, our database. And it uses CloudTrail And it's storing all these logs into an S3 bucket. And that's the key. That's the key. And it's all done for you. And it's all done storing all your information for long-term storage analysis. Okay, let's get involved into AWS Config very quickly, then we'll take a break and answer some questions. AWS Config is a service that enables the assessment, auditing, and evaluation of configurations in AWS. It provides an opportunity to see what changes were made and by whom. When a change is made in AWS Config, it can send an SMS alert to systems admins. How cool is that? Somebody does something and you get notified, hey, by the way, somebody made a change. Pretty helpful if they're not supposed to be making changes. In like a production environment, for example, people don't make changes during the day unless it's an outage or during high periods of use. And knowing when somebody made a change when all of a sudden you have a problem is pretty great, so you know how to revert that change. So config is going to provide constant monitoring of all configurations. It's going to check these configurations against an organization's policy. And that way, if a change is made that violates the policy, you can get an SMS alert. Remember those notifications? And a CloudWatch event will occur. And because the CloudWatch event occurs, we've got options. We can basically set up a Lambda function to remediate that event should we need to. It can tell us that something was done, so if there's a problem, we can go fix it. And we can integrate this with CloudTrail, so when a configuration changes are made, we know what it is and we can fix it should there be a problem. Now, Chris, let me answer some questions. The next section is CloudFront, and CloudFront gets pretty complicated, so let's take a break here. Get to some questions. Can't wait till after you can tell me who just got hired today. An application will ingest data at a very high throughput from many sources and must store it in an S3 bucket. Well, we're going to talk about Kinesis and the different ways that we can store Kinesis, but it could also be done with Kafka. Kafka would probably be the best way to do it because that way we can use it across all different clouds. But there are some AWS proprietary services called Kinesis, which we'll get into soon, but we'll discuss that. Is a data lake like a data warehouse? Not at all. So a data warehouse is basically a giant database that stores stuff. Typically Postgres, AWS has the Redshift. What a data lake is, we pull the information out of a data warehouse. We pull the information out of our relational databases. We pull the information out of our NoSQL databases. We pull our information out of object storage. And by comparison, then we do this, then we put it into a data lake. So a data lake is the aggregation of all of our structured and unstructured data. Azure Monitor equals CloudWatch, pretty much the same thing. Hi, AWS Keyspaces is a serverless managed service for Cassandra, yes. With that said, is it hybrid? Look, anytime it's a managed service, there can be any tunes to it. Now, here's the thing. I want you to think of the difference between managed service and do-it-yourself service. So in an infrastructure as a service environment, you manage it. Let's prepare the tale of two services. We've got a serverless service like Keyspaces. When you go to Burger King and you say, or McDonald's, and you say, I want a Big Mac, it comes out consistently the same way every time, and it's good enough quality. Now, if you go to Morton's Steakhouse and you tell the chef, I would like you to use prime beef. I would like to cook at this temperature. I would like these spices in there. I would like these vegetables on it and this kind of bread. At Morton's or any other great place, they can make you a much better hamburger than you got at McDonald's. Anytime you go serverless or any of these SaaS, any of these applications where it's managed for you, you're getting McDonald's. Now, McDonald's is generally good enough for most people to eat their meal. But if you need better, and you need the better performance, better tuning, better security, better anything, you're going to make it yourself. So look at it this way. You manage your own Cassandra across your 5 clouds. You know exactly what it is. You do with managed services, and it's like your internet service provider. Sometimes it's good, sometimes it's not good. And don't get me wrong, the services from the cloud providers are great, but you're always going to have more functionality and features and obvious things than when you do it yourself than when you go serverless. But serverless is simple. Audit logs get rotated in an S3 bucket. How do you keep those logs? Who said audit logs get rotated in an S3 bucket? You can keep those audit logs forever. There's no time limit on how long you can keep logs. Almost. Okay, let me explain what architecture is and why this is never possible. You can never have a giant architecture related to the services. And here's the reason you're asking this question, Amos. You're confusing engineering with architecture. In engineering, you can come up with the best practice. Here's your virtual machines. Here's your containers. Here's how you plan them. In architecture, your goal is to solve a customer's business problems and improve their business performance. Now, a hamburger joint needs a different architecture than a coffee house, which needs a different architecture than a music store, which needs a different architecture than a music studio, which needs a different architecture than a bank, which needs a different architecture than a finance house. And not only that, but the problem is as follows. 2 different banks have 2 different business models, and hence they need 2 different architectures. And that's why architecture is not engineering. And that's why I tell you, if you want to be an architect, you can't be focused on configuration or the technology. You need to be focused on what are the business things that you're trying to solve. So when you speak to that CEO, and yes, you're going to be speaking to CEOs of billion-dollar companies, as an architect, you're going to be able to understand the business problems they're trying to solve. So you have the business skills called business acumen. Then you'll be able to take their business things, create a team of the 50 people plus that you need to design the solution, document the solution, present it back to the solution, and go sell them that solution and build a business case. So no, there's never a possibility to have a giant architecture. That would be effectively saying, doctor, you can only have one pill. You're going to memorize this one pill. But the key is for a doctor to make a diagnosis and know something about this. You need to know all about the patient, all about the body systems, all about reading labs, all about the study of drugs called pharmacology, how to prescribe drugs, diagnose and assess. And that's why this is not engineering. This is every much as much art as it is a science. No memorizing anything in architecture. Can I rate the difficulty between the Solution Architect and Solution Architect Pro? I would say you could pass the Certified Solution Architect Associate in a week, and the Certified Solution Architect Professional would take you a month if you had a good, accurate study plan. Still basic stuff, both incredibly basic. But the Pro, they ask questions in a much more challenging way, 3- and 4-word sentences that are written poorly. The Associate's pretty straightforward. Okay, before we get back to the content, if you can give me a hashtag AWS Certified Solution Architect Associate. And if you've not liked it yet, please like, please subscribe, and please hit the bell. And before we do this, we'll answer questions like Cash. Like Cash's real quick question, do I need to learn Apache Kafka? Well, it depends. Are you an architect? You need to know what Apache Kafka does and how to integrate it and its strengths and weaknesses, but we don't touch the tech as an architect. Now, if you're going to be a big data engineer, then yes, you need to get real familiar with Apache Kafka. Okay, I'm seeing it. I'm not seeing enough subscribes and likes yet, though. Maybe help us out with that. I'm looking to check and see if you guys are paying attention to us. We work pretty hard. I'm doing with laryngitis, drinking a turmeric and a ginger tea, trying to soothe the throat. So give us some likes and comments, please. Okay, now let's talk about CloudFront. CloudFront is something I love because it's a content delivery network. And I love content delivery network. Why? They improve performance and enhance security. Nothing better than improving performance and enhancing security at the same time. Plus, content delivery networks in many cases can even cut your costs down. So improving performance, improving security, cutting costs. Can you imagine how awesome this stuff is? Love it, love it, love it. It doesn't get any better than this. So when you're dealing with multi-clouds, you're going to need multiple content delivery networks. Why? A single content delivery network is a single point of failure. Don't believe me? The entire country of India was nearly taken down because it was relying predominantly on a single content delivery network. That went down. Half of India's internet access went down. Real businesses that are high availability use multi-clouds and multi-content delivery networks. But we're on your certification, we're going to talk about the CloudFront. And CloudFront isn't exceptionally good, just like these other content delivery networks. It's the Amazon branded content delivery network. And what is a content delivery network? Everybody's going to tell you that it's a geographically distributed group of servers. It is a group of servers, but it's also a network, which means it provides private network access, high performance network access, and user caching with the servers. So this will provide caching and many other optimizations. Now, CloudFront or any content delivery network can dramatically improve your web hosting performance. Now, CloudFront's integrated with a lot of AWS services, making it simple and elegant on AWS. Here's what's going to happen when a request is made. And I'm going to graphically show you this in a minute. What's ultimately going to happen is it's going to hit the CloudFront content delivery network. So here I go. Here's an example. Today, I want to go to www.cindythecutecat.com. And when I go to www.cindythecutecat.com, I go to the CloudFront distribution. Mine is in Miami. And there's nothing there on the CloudFront distribution. So I hit the CloudFront distribution. It goes to the Cindy the Cat website. It gets sent back to CloudFront. And then it gets sent back to me. Now my wife wants to see Cindy the Cat's videos. So my wife uses the computer in the other room. She goes to the CloudFront distribution and Cindy's photos and websites right there because I just accessed it. Now Child comes and visits me in Florida and she wants to see photos of Cindy. So she's at our house in Florida. She goes, she gets instant access to photos of Cindy. And we're all happy. And the only time the website actually have to answer the request was for me. And that's why we love these things. So what happened is if I get 100 more requests in Florida, the cache will answer it 100 times. So that took 99 of those web requests off of me, and they sent it to Cindy, 99 requests off of the web server. So you can see huge amount of scalability here. So what will happen is the CloudFront servers will speed content, they will reduce loads, and in many cases, they'll reduce costs. Because what will happen is, let's just walk you through it in the graphics. So in this graphic that I'd like to show you, here we go. Now, here we go. Your first person makes a web request, and it hits the CloudFront location. If it's not at the CloudFront location, what I'll actually go to is the regional cache. And if it's not on the regional cache, what's going to happen is it's going to ride the Amazon internal network, not the public internet, to that S3 bucket, which is the source of my static website. So request immediately hits CloudFront. CloudFront, if it has it, it's going to send it back to me. But if it doesn't, instead of using the public internet to get to the website, it's going to jump on the express highway lane, the private network that AWS controls, and go straight to the S3 bucket. So it's going to get off the internet onto a better network. Now then, what'll happen, the asset will leave the S3 bucket, it'll sit on that CloudFront cache, and it'll be sent to me. Now, the second request you can see on the user on the bottom, the user requests the same thing as the previous person, and it goes to CloudFront and it's answered. So now think about this. In a DDoS environment, if I had 100,000 requests to that Miami CloudFront location, and they were all valid requests, CloudFront would handle the 100,000 requests, which means my web servers don't. You see how that helps? Now, what if we were dealing with inter-regional charges, like AWS bills you in between regions? Guess what? We don't have to worry about that either. And why do we not have to worry about that either? Because the content's cached and it's not constantly transferring across the inter-regional divisions. So we can save a huge load on our servers, and at the same time, we can increase security and cut our costs. So when we're talking about these things, what are we really dealing with? We're really dealing with website scalability. We're dealing with increased security. And we're dealing with things. Now, when does caching not help? If all of our website stuff is dynamic and changing every minute, and every user is accessing different information, now caching will actually increase latency and reduce the effectiveness. So like all architectures, we must know what is our usage patterns prior to deploying any piece of technology. Hence the reason the most critical skill for the cloud architect, solutions architect, is communication skills to find out the customer's business pattern. Because the business requirements drive anything. It's not, the tech doesn't drive the business. That's like the tail wagging the dog. The business determines exactly what technology we use as architects. And engineers, we hand them a piece of paper, they're geniuses that say build this, and they build it. Different job, different role. So CloudFront's going to integrate with a whole lot of AWS services. It'll integrate with your basically S3 if you had static website content, your EC2 instances and load balancers for dynamic content. It'll work through Route 53 for your DNS. Again, if you're using multiple cloud providers, you're not going to be using Route 53. CloudFront could be used as a front end to a static website. It can also be a front end to an EC2-based website, assuming a load balancer is part of the architecture. So realistically speaking, what are we actually dealing with? What we're dealing with is the following. We're dealing with CloudFront being the front end to static content on an S3 bucket and the dynamic content of our website. And why might we do this? Well, we may have a bunch of pictures and videos, and the cheapest place to store them is putting them on the object storage. And for example, you know, what we're dealing with regards to the front end, the EC2 instances, that's for our dynamic web pages. Let's talk about some key concepts with regards to CloudFront. We're going to talk about distributions, origins, and cache control. A CloudFront distribution is as follows. It's basically identified by your DNS name. And it's going to look like abcdefg111.cloudfront.net. In fact, if you were here the day before, I'll do it one more time in case you guys didn't remember the other day. Bear with me a second. Chris, I'm going to try and share something in a second. When I do so, please share the window for me. Okay, Chris, share this window from my Mac. It's my terminal window. And here we're going to do an NS lookup. We'll identify our name servers, and we're going to do www.amazon.com. Here, what you can see over here is we actually have this ugly name. And look at which CloudFront they're using right now, which content delivery network they're using right now. They're not even using their own content delivery network. Who knows, maybe something's going on with CloudFront. And you can see that Amazon.com is actually using Akamai's content delivery network. And you can see this Echo 15316-Delta Sierra Charlie Alpha.akamaiedge.net. So right now, Amazon is using the Akamai's content delivery network. 2 days ago, it was using CloudFront. And in this particular environment, maybe CloudFront's down. And that's what we're dealing with. So this is actually the new URL of your company once you use a content delivery network. Now, clearly, we want to use Amazon.com and not this ugly thing. So what ultimately happens is we'd create a CNAME record that'll map Amazon.com, which is user-friendly, to this ugly looking thing, which is on the Akamai network, and here's its IP address. Oops, not what I was trying to send there. Okay, thanks, Chris, for fixing that for me and reading my mind. Chris, you're fantastic. So
I know, thank you.
Thank you. Seriously, Chris is my chief operating officer. He's amazing. He doesn't need to be producing my stuff, but he makes sure that we're successful, and I feel extra safe knowing he's behind the scenes. So let's talk about the CloudFront origin now. When you set up CloudFront, you really have to specify an origin. And an origin is really the location of where your content is coming from. Whether it's an S3 bucket, the load balancer that's front-ending your website, where's your content coming from? That's the CloudFront origin. And anytime you're setting up a content delivery network or dealing with a cache, you're going to have something called cache control. The whole point of CloudFront is to cache or temporarily cache the information. But let's talk a little bit about caches and cache control. By default, your information is cached for 24 hours. 24 hours. Now, why is this done? Well, if I post a photo of my beautiful Cindy the cat, she's the cutest thing I've ever seen. Of course, I'm a little bit biased. And you see the photo of Cindy the cat. Now, if we cache it for 24 hours, for the next 24 hours, the cache will hold that Cindy the cat photo so the website doesn't have to respond. Now, this is good if the website doesn't change more than once every 24 hours. More scalability, faster web load speeds, all great things. But what if Cindy likes to post on her website 4 times a day? She's got one where she's laying on her back with her hands in the air, another one where she's sleeping. There's a video of her doing a flip to chase a bird outside the house. And there's another photo with a little lizard in her mouth that she just brought in to surprise me. Now, if we cache it for 24 hours, the only people who are going to see the first photo, nobody's going to see the second. And Cindy the cat will be angry that nobody's seeing her new photos on her website. So then we would reduce the cache to change more frequently. So longer cache times out, more scalability, but the people won't see new updates on your page. Shorter update times mean lower performance, and the cache is going to time out more frequently and more workload for your servers. So what drives this? Your usage pattern. Like everything else, it's based upon your business requirements. So part of the things the architect would have to interview, let's say Cindy was the actor and actress here, we'd have to have a conversation with Cindy. What's your publishing schedule? What's on here? How many times a day do you want people to see your new photos and videos? So that's where you'll have to get it from your customer. Find out your customer's business pattern for your page, and then determine the appropriate cache control, which is also called the TTL. Now, if any of you guys and girls have ever worked with a cache before, or dealt with anything, you know, periodically systems get corrupt. And if you have bad data in your cache, you could be spending bad data for upwards of 24 hours to your customers, and that would be real bad. So you can always clear the cache. Keep that in the back of your mind. So let's talk about setting up the CloudFront distribution. How would it be done? Well, basically, you set up your web servers and put your content on them. After you set up your web servers and you put your content on them, you're going to create the CloudFront distribution. AWS will give you one of those ugly, ugly, ugly domain names. And you can either accept that domain name, or you create a CNAME record like AWS did, and they will provision your edge computers. Like I said, never use a single content delivery network. And as you can see, when we did this 2 days ago, Amazon was using the Amazon Content Delivery Network a few days ago, and today they're using the Akamai Content Delivery Network. So even they use multiple service providers, as do we all. So now let's walk through CloudFront one more time. It's something I showed you on the first day. Here's basically the architecture. You got your regions, which are your giant geographic areas. You've got your data centers inside of each geographic area, called availability zones, and then we have your edge locations. Now, how's it going to work? Let's do it one more time. Let's take the user in the upper right-hand corner. Hi, I'm a user. I request a web page, www.gocloudcareers.com. I hit the edge location. It's not there. So my request hits the edge location. It hits the regional cache. It's on the AWS private network backbone, their content delivery network backbone. It gets sent to the source. It gets sent back to the regional cache, which gets sent then to the edge location, which then gets sent to the user. Now, the subsequent users that hit that same edge location in the top corner will basically get it immediately. Now, if a user on the bottom edge location requests a photo from www.gocloudcareers.com, if it's not on the cache, it'll go to the cache, the edge location, hit the regional cache, ride the private network from the content delivery network back to AWS, come back to the regional cache, put it on the edge location, and then give it to the user. And that's how these things sort of work. And that's how they help. Let's talk a little more about what we're dealing with. CloudFront, as we mentioned, can increase website performance dramatically because it caches your content. At the time we made this, there were 217 points of presence for CloudWatch. I'm going to tell you right now, that's always going to change and grow. It helps with your routing efficiency for the following reason. Normally, your web requests would traverse the public internet, but there's no guarantees of performance on the public internet. So what you really want to do is you want to use CloudFront, either hit the cache, jump off of the public internet, jump onto your content delivery network, use that higher speed content delivery network to go back to the source. So no matter what, it's going to increase systems. Now, it can help with your routing efficiency, as I mentioned, because you're going to traverse the AWS network, not their content delivery network, not the public internet. And CloudFront also maintains persistent connections to the source. So you're not starting a new session with the web server for every request. So that TCP SYN and ACK and SYN-ACK that were necessary to open up a connection, it's already maintained. So it's further going to reduce the latency. Content delivery networks are excellent, but you need multiple ones. CloudFront, you can obviously put your web application firewall there, but you can also put your shield there. In this way, your DDoS protection can be straight on the content delivery network. Before they hit your firewalls, before they hit anything, block all bad requests before they ever get to you. So all content delivery networks dramatically increase in distributed denial of service attack prevention. And by being able to put Shield directly on the content delivery network, you get it. Then again, Akamai's got their own DDoS protection. Microsoft's content delivery network has their own DDoS protection. Cloudflare is another content delivery network. They've got their own DDoS protection. So this is normal functionality with regards to a content delivery network. But again, that ability to terminate your SSL HTTPS connections on the CDN without even hitting your servers reduces load. The ability to make sure that the servers don't have to answer to everything, only new responses reduces load. So increased speed, performance, and in many cases reduces cost. Now, CloudFront can also provide your encryption in transit because it can enforce SSL/TLS protocols. It'll integrate with many services such as the Certificate Manager, and CloudFront supports server name identification and custom certificates. Now, normally speaking, use CloudFront for a public website. But what if you wanted a private website, for example? Paid website subscribers, private applications. There are a couple ways to do this. We can set up an origin access identity, and we can restrict the data to, say, an S3 bucket to certain individuals. We can use a signed URL, or we could use some signed cookies. And that's where we're at for right now. Let me very quickly do something about some Lambda functions. And after Lambda functions, we'll take some questions. So let's talk about Lambda next. Lambda is a serverless computing service, and it's used for micro things. Basically, you upgrade the code and the Lambda function works. It's the same thing as an Azure function, for example. And there's no need to manage servers or operating systems. It's basically quick and dirty things. C#, Java, Node.js, Python. Basically, it's a way for you to automate simple things. The way we're going to use Lambda is as follows. The user is going to update their code. And when something happens, the function is going to run. And we're going to pay every time that Lambda function runs. Lambda is stateless, which means it doesn't track anything. Functions performed and completed. If you need another function, you're going to have to set up another function. It's not looking at a multi-step function without doing something else. And therefore, Lambda is useful in many situations where automation can create an increase in efficiency or decrease manual intervention to process data across multiple systems because your S3 buckets, for example, got hit by a security event, patching at an operating system, for example. Now, a Lambda function can respond to an event. You misconfigured S3 bucket, ding, 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 run, fix something. A user can, or for example, we could create our own thing. For example, let's walk through something that here would be a great place for a Lambda function. Let's say, for example, I wanted to upload a video to S3, and I had a multi-step video process. I could create a Lambda function to have the video transcribed, and another Lambda function to basically have the video converted from, say, raw video to H.264 or H.265. I could then even have another Lambda function to send me an email that says, hey, Mike, your video is ready. It's been processed, transcribed, go download it. So Lambda is really about automating. These compute Lambda functions are exceptionally good for digital transformation. One of the things we absolutely love about the cloud or something like this. It's complete. Now let's talk about Lambda Edge. Since we just talked about CloudFront, what if we wanted to run a Lambda function basically right next to the user? Well, we use Lambda Edge. It's completely serverless, and it works with the CDN. So let's talk about Lambda at Edge. And Lambda at Edge, basically you upload your code, and it'll run directly basically by your CloudFront location. Very simple and elegant. While we're tying Lambda together, we're going to enter step functions, and then we're going to go to questions and answers, and we probably should end right there. So let's talk about step functions. If you've got multiple Lambda sequences, I mentioned they're stateless, you're going to need to schedule them. And that's where step functions comes in. It enables you to create step 1, step 2, step 3, step 4. So execute step function 1, execute step function 2, execute step function 3, execute step function 4. So how's it going to work? You design the steps of the application. We create individual Lambda functions. We're going to configure the workflow in step functions. We'll connect the workflow components to the individual Lambda functions. Each function will execute its step, and it will optimize and evolve the data functions as needed. Here's a graphic for how that works, and then I will take questions. Basically, step 1, step 2. So step 1, Lambda function, step 2, Lambda function, step 3, Lambda function, step 4, Lambda function. And that's really, really what we're talking about. So let's do this. Give me a like, give me a comment. We'll answer some questions. And then what we'll actually be dealing with is we'll get prepared for tomorrow. We'll talk about what's coming on next, because we're going to finish it off tomorrow. What's the difference between Elasticache and CloudFront? Well, Elasticache is a proprietary version of a Redis cache that's fully managed, that's used for databases. And CloudFront is a content delivery network that's used to speed up web pages. So they're totally different functions. When do you use Global Accelerator, and how is it different than CloudFront? They're not even related in any way, shape, or form. What is Global Accelerator? If you're going to send your data across a network, by using an accelerator, you can send it to a place that's closer to you to get your data to AWS. CloudFront is the content delivery network for your web services. So, one, you want to send your data to AWS. We can use Global Accelerator for that, and we'll discuss that as we get to that in the class. CloudFront is specifically for web applications, for caching web applications. Good question, though. We'll discuss Global Accelerator tomorrow. Are CDNs configured with respect to routing policies, AC legacy routing? Godson, this is completely different than BGP and OSPF and any kind of routing things we're doing. The content delivery network will, of course, be a network. And of course, as a network itself, it will need its own interior gateway protocols and routing protocol policies, but totally different kind of concept. Not even related. And it's not related to DNS either, which is what you're talking about, which is another form, which is mapping the names of locations. So to me, legacy routing is OSPF and things like that. I think you're asking with regards to latency routing, which is related to DNS, but latency routing could also be related to software-defined networking. But content delivery networks aren't configured anything like that. It's caching for your users. So basically, the web server can serve it. It can be stored on a cache, and then from there, it can be sent to the users. Christian, go to the next question. Saw that, Chris. And interact with the poll while we're at. Vote for who's ready for tomorrow. CloudFront is a network itself. Yes, it's a content delivery network. And the edge location is the entry point to that network. Yes, Mauricio, good job. Okay, wow, no more questions. That's absolutely incredible. Love that, love that, love that. So either I did a really good job or you guys are sleeping. So do me a favor, give me a hashtag AWS Certified Solution Architect Associate and give me a hashtag We Finish Tomorrow. So I know both that you're here, awake, alert, and oriented, and you heard me. Takes a lot to deliver a boot camp like this. A lot more when you've got laryngitis and I'm drinking this ginger turmeric combination for inflammation. So a hashtag AWS Certified Solution Architect Associate and a hashtag We Finish Tomorrow. And I hope you guys are having fun. And if you are, please give us a like. If you've not subscribed, please subscribe and hit the bell. And please tell others to go watch this free video so they can get training. And vote on the poll. Good, I'm loving this. Thank you so much. Hand of God. Marie George, Solution Architect. Marie George, are you who I think you are? My good friend, husband. I mean wife? Oh, that's Marie Claire. Marie Claire, so happy. Cloud Certified and Cloud Hired. Congratulations, wonderful. Isaac Wave, Certified Solution Architect Associate. We finish tomorrow. Love this. Jason Trumpter, we finish tomorrow. But please give me that hashtag AWS Certified Solution Architect Associate too. Mauricio, Certified Solution Architect Associate. Collins, always good to see you. Victor, Isaac, we're so happy to help. Godson, we finish tomorrow. Mauricio, Cash, we finish tomorrow. AJP, good to see you. Al. Shameless, so nice to see you. And the God, we finish tomorrow. Emmanuel, we finish tomorrow. Eva Doike, you love ginger. I love ginger too. You brought your friend to watch this week's workshop. I'm so happy you did, Anakin. Spread the word. Share the free training with as many people as you can. Only 54 votes? Are you serious? Participate. Life's more fun when you participate. I used to be the introvert that I'd go to a party when I was younger with my wife, and I'd hide in the corner. And then she'd say, start dancing. And before I hurt my foot, I started dancing and had a lot more fun. We just talked about Lambda. If you have a specific question about it, Keith West, we finish tomorrow. And Eva Doike, we finish tomorrow. We are so happy to help, Victor. Anyway, I hope you had a great time. We'll see you tomorrow at noon. We'll finish up tomorrow. We've gone through a big, extensive week. I hope you guys all learned a lot. Did you guys all learn a lot? Tell me in the chat box. Lady Godiva, so good to see you. Yasmin, love that name. Yes, I'm ready for more. Good, good, good. That's why we do it. That's why we do this free training, to make sure anyone, no matter where they're at, regardless of their financial status, can learn some more. It's been an honor and a privilege to spend most of the days this week for you. Keith, I will join you for some Silver Oak and some McAllen 25 as soon as we get you to a certain point. It'll be you, me, Matt, and of course Heidi, and we will have fun along the way. What's the difference between Lambda and Fargate? They're not related in any centered way. Lambda is a simple function, and Fargate's a place where you can store your containers. Jason learned a lot. Good. Learned a lot. I love this. Yes, you did. Collins, I always appreciate your nice things. And yes, Yasmin, we finish tomorrow. So happy to see you all. Thrilled. It's been wonderful. Alexandros, Yasas. ATP, thank you so much. Godson, it's been wonderful. And we're thrilled and honored to always help you. Thank you so much. Have a wonderful day, and I'll see you all tomorrow. And before we do, let's make sure a few things. Make sure if you haven't downloaded the completely free AWS exam guide that you do so now. It'll help you with the AWS Certified Solution Architect Associate and the AWS Certified Solution Architect Professional exams. If you've not done the hands-on labs, please do so. Sign up for the free hands-on labs at the AWS lab, for the AWS lab demonstrations, so you can do them too. Is in the chat box and the link below. And please join us on Thursday so you know how to get your first cloud architect job. It's a completely free webinar. The link is in the chat box and description below. I promise you're going to learn exactly what you need to learn to get hired. And if you want to get cloud hired, take advantage of our 30% off special coupon code SECURITY, celebrating Cyber Awareness Month. We had another cloud hired today, 2 cloud hireds yesterday, and our students, regardless of their background, get cloud architect jobs as long as they do the work. And I want to help you all get cloud hired. So take advantage of any of our programs, like our Cloud Architect Career Development Program, and get 30% off using coupon code SECURITY. Hope you all had a wonderful learning experience, and I can't wait to see you soon. Take care, everyone.